Everyone, as dawn unfolds, nature paints a serene canvas. Step into the symphony of intellect, where algorithm compose the future, data conducts the present, and together we harmonize innovation in the grand orchestra of unseen possibilities. A warm welcome to the dignitaries on and off the dais, the faculty members, and my fellow students to the 2 days international workshop on applied generative AI, organized by the Department of Information and Technology, PSNACET. I welcome you all.
Let us invoke the God's blessings on all of us through a prayer song. I would like to invite Praveena and Madangi to glorify the Lord through their divinely prayer song and grace this occasion. I kindly request all of you to stand for the prayer song.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि श्रीगणेशाय धीमहि श्रीगणेशाय धीमहि.
Great honor and privilege to extend a warm invitation to an esteemed personnel, Dr. A. Vincent Anthony Kumar, Professor and Head, Department of IT, to deliver the welcome address at this event. He has been a guiding force within our department, leading us with unwavering dedication and inspiring us to reach new heights of excellence. With his vast knowledge and expertise in the field, he has been instrumental in shaping the success of our department and fostering a culture of innovation and collaboration. I welcome you, sir, to address the gathering.
The most chairperson, Tirumadi K. Dhanalakshmi Ammal, and our vision leader, Rotarian R.S.K. Raghuraman, pro-chairman of this prestigious institution, our beloved principal, Dr. D. Vasudevan, in absentia, and today's chief guest, Mr. Farang, CEO and founder, Broadback USA, and our distinguished guest, Ganesan Naranaswami, a distinguished lecturer and technology leader, University of California and IBM Global Leader, Open Power Foundations, and Dr. Bhumishwaran, the radiologist from Ireland, and also Mr. Shivakumar Shanmugam, Werner, the largest logistic company in USA, and Mr. Niranjan Kumar, AI researcher, TUEM Germany, and Mr. Premnath, the senior lead, Ericsson, and Mr. Nagaraj Trivedi, senior architect, Mr. and Mr. Ramesh Krishnan, data architect, object automation, and Mrs. Kamini Madam, object automation, solution, Chennai, and as well as the UNS. And our Dean Research Sir, esteemed heads of the various departments, professors from other department, and faculty members of IT, and dear student friends. A warm welcome to one and all gathered here. So I'm just standing before you to welcome, giving a short welcome note for the 2 days international workshop on applied generative AI. So everybody is talking about AI, everybody is talking about computer science, everybody talking about the IT industry, everybody talking about the automations. So what is ChatGPT? So what is Gen? What is generative? What is AI? Generative AI is nothing but a subset of the artificial intelligence, what we studying about it. We have a curriculum of artificial intelligence data science. So here, all third year IT and other branch students are here. We now focus on data science. We focus on data. We focus on chat GPT and everything. So in this concept, I think I discussed with Ganesan Naranaswami sir the 3 months before. He immediately agreed. I think now he is in US and taking care about the lot of technology, tech stuff there at the US at California University and all other, the IBM too. And he accepted our invitation to come over to the India for the many reasons. So I invited for the PSNE CET, he accepted, and also he suggested the Frank sir, and immediately sir also accepted. I think we have a very good collaboration with the IBM and as well as the Open Power. The last 3 years, during the Corona period, we conducted the mini international workshop through online. I think I attended the Farang sir lecture through online, and I attended the Sivakumar sir lecture on online, and he is the great persons, industry persons, are come over to our PSNA CET and they are with us. So first of all, I would like to thank all the resource person accept our invitation. And on behalf of the management, on behalf of our college, on behalf of myself, and Department of IT, on behalf of the students. So I welcome every one of you to be here at our PSNA CET campus. And I welcome all the student delegates and some faculty members from other colleges also participating here. I welcome all the faculty members and the students' friends. And really, you are going to take a good stuff from the US. We talk about the generative AI, which involves the deep learning technique, the models such as generative, I think we worked about in the research, we talk about the GAN. So it's a basic of the GAN networks and other things. Already we have, I think all second year and third year students might have studied about the artificial intelligence and as well as the data science basics. Now, today, they are going to give a wonderful lecture on the different applications. When I talk about the AI, what are the applications we have? So we have industry application from the semiconductor industry. I think Farang sir is there. Enterprises AI, I think Ganesh sir is going to give a lecture. And medical images, medical data, I think sir, Bhumiswaran sir is available. And logistic operations, I think Shivakumar sir is available here. So on behalf of all, once again, on behalf of the students, I welcome all our dignitaries from the global leaders from all over the world. I think they are present here at the PSNA CET in the 2 days international workshop on applied generative AI. So thank you for giving me the opportunity. Once again, I welcome you all. Thank you.
Manifestation of nature brings out the joy in the environment, enlightens even the darkest of places, and brings about the true blessing of Mother Earth on us. To illuminate the young minds to enlighten this auspicious occasion, I invite our honorable chief guest and Dr. A. Vincent Anthony Kumar, Sir, Professor and Head, Department of Information Technology, to lighten the lamp and grace this occasion.
Technology makes possibilities, design makes solutions, art makes questions, and leadership makes actions. It is such quality actions by a leader that takes us to the next level of growth. I feel profusely overjoyed in introducing one such person, Mr. Ganesan Naranaswami, Senior Technical Computing Solution and Client Care Manager at IBM. He is an enthusiastic person with profound technical skills. He has spent 13 years in IBM US, becoming a member of the firm's management team. He also served as a cluster manager for IBM's STG division. He held the responsibility for driving marketing across IBM for cluster system management software. With that now, I would like to invite Mr. Ganesan Naranaswami to address the gathering. We are highly excited to hear from you, sir.
Good morning to all. Once again, I'm here, and I got a big team here, as Mr. Vincent sir said. It's not actually just we are going to do a presentation. There are a lot of the practical things also going to be involved as part of this. And also, I just want to mention what is happening in today's world. Everywhere the people are driving for opportunities, and each and every industry. Like I would say, I have worked with at least 18 industries where I see every place people wants to apply artificial intelligence, and that is how the things are transforming right now. And even healthcare, like we have definitely the chief one of the guests here who is going to speak about it. Transportation, we have chief guests going to speak about it. Like that, many industries looking for applying artificial intelligence and see how they can leverage the features of AI and deploy it. And this is going to happen for next 10 to 20 years. And by the time, like 2047, I would say, even Prime Minister of India, Modi, announced India will become a developed country around that time. I'm hoping so for that. And during that time, certainly this artificial intelligence will work out very well, in all the industries. And one example is, what I have been seeing in healthcare. There are a lot of organs in our body, need attention every time. Once the person, it doesn't matter, even the childhood days, as well as, like millennials and, and later on, like an aged person, we need to monitor the organs. But with the help of artificial intelligence, certainly, these organs will be monitored. How? One can ask the question, it's going to be using a chip, a processor, and that's going to be the size of the nail. And now, recently IBM innovated a chip with the 2 nanometer. That is nothing but a size of the nail, and that you can insert in your body, and that one, through IoT kind of capabilities, you can enable artificial intelligence and monitor all your organs. And what will happen next? What the famous doctors in the world, talk about it is actually there is no death. The death will become optional, and that's a strategy, going to be, and that's a future, and that's how I want to connect here how important the artificial intelligence, in today's world. And with the, definitely, there are a lot of, things, are there as part of that. As, as Vincent sir said, the subsets, like we are talking about deep learning, machine learning now. Generative AI is a new technology which got in, and you guys definitely need to learn about it. And that's how this 2 days workshop going to be. So with this, why I said about the chip and the solution, we have team here, and who is going to talk about it. We have an expert from Silicon Valley of US. Which one it is? Do you know that? Which one is Silicon Valley of world? Which city or which place? Do you guys? Silicon Valley of India. Okay, that's good. Bangalore. But there's not much silicon there, not much manufacturing happening, and not much, design happening in Bangalore. Mostly, I would say that, 90% of the people are doing support and other stuff, but maybe remaining 10%. But Silicon Valley of the world, San Jose, and, we call it, the Bay Area and all those places, in California. That's a place, lots of, the development of, whatever I said about, the design, development, and test, all the things happening there. And we have Farhang Yazdani, who has been working with, a lot of the silicon engineering people, and also he also was part of U.S. Department of Energy, the DARPA funding project, and he has been successfully taping out, silicons, in U.S. And he's here with us, to talk about, some of the advantages, and then the futures of, what's going to happen, using the silicon, whatever the size of the silicon and all those stuff. I strongly welcome, him for the part of the workshop today. Thank you, sir, for coming over here. Really appreciate it. And, this is a great opportunity. It's not just for IT. I know that, here we have set of IT, the Bachelor of Engineering IT people are here. But it's not just for IT. It is for all the engineering department, the silicon can be used. So, he's going to be talking with, some other department too. Make use of opportunity and see how you can, apply that in your career. And that's the only request I'm making here. And then I'd like to invite Shivakumar. He has been, known to me like for the last, I would say 28 years, since 1999, 98 time frame. We connected and we have been having a good connect and network, and also a lot of collaborative things, we have done in the past and now, currently also. And he is currently working with a company called Warner Enterprises. That's basically, as Dr. Vincent said, a logistic company. That means what? A truck company, there are a lot of trucks, there like, 25,000 trucks, they own. Basically, they, a lot of customers, use the truck to deliver the things from one place to another place. Certainly, AI can be applied where? There are a lot of, operational things, AI is very useful. And he's going to be really talking about those use cases. How Warner Enterprises applying AI and how that is getting evolved and all the stuff, he's going to be talking about. Even the software stack as well as hardware stack, one of the, longest IBM customer too, they use IBM mainframe. And he's going to be sharing the experiences, with you all. This is a great opportunity for you, to see a real use cases, in front of you, going to be, and how you can apply that in your career. Shiva, welcome you for this workshop. Thank you very much. And I have, as I said before, the healthcare and all the stuff, that's the future of, the AI, future of the world and a lot of stuff. We have Dr. Bhumishwaran from Ireland. He's a radiologist, and he's going to be certainly sharing lots of his, experiences, working with AI and how that is getting evolved, and, how it is being used, by the customers, various customers and the hospitals, hospital management, and many experiences, he's going to share with you all. It's a great opportunity, to learn from him and see how you can adopt it, in your career today and also the future. I know that, many PSNA in the past, the people, moved out of India and, they are working in other countries like Europe and US. And certainly, you guys also will be there. And this is a great opportunity for you to listen to his presentation. Bhumishwaran, thank you for coming over here. Really appreciate it. Thank you. And I have I have Premnath from Ericsson. And he got recently connected with me through my another friend who is well known to me for the past 25 years. And he's working in the 5G technology. How many of you know what is 5G and how the 5G is very helpful to the world? How many of you know? Application-wise? Oh, only faculty. Okay, students, do you use mobile phones, right? No mobile phones here? Okay, it's a little surprise for me. So you will get, in that mobile phone, there is an option, where you have to choose a 5G or a 4G network or even 2G. 2G is very famous in India. So, a lot of the political background here. But the 5G, that's basically getting deployed everywhere in US and Europe and India. Even the service provider like Airtel or AT&T or any other service providers, now adopting 5G with lots of, investment. And Premnath is going to be sharing what is 5G and how it is being used by all of us, and also how the edge compute and 5G connection, and how it is actually creating opportunities for people, and you guys definitely will be learning something. Maybe since you do not know about 5G, you will learn something new for sure, and that is also another future. I just want to give you an example of it. There are a lot of people like universities in the US and I have Nagraj from Minstrel, Bangalore, and he's actually one of my friends, friend, and he's supposed to come for this meeting, but he couldn't make it due to a unavoidable thing, where he has to travel to Japan, and now Mr. Nagraj is here, and he's going to be sharing about some of the deep learning experiences, whatever he has, and that is going to be kind of a real-time kind of a scenarios also he's going to be sharing. I welcome Nagraj for this workshop. Thank you very much. And Mrs. Kamani, I'm sure you might have seen her in the previous workshops. How many of you know her from object automation? She has done some workshops here, and she is very meticulous in delivering the deep learning, machine learning kind of a concept to solution, and she has done at least maybe I would say like 12 to 15 workshops like that, where you guys will learn about the concept and also how to deploy that in a real life real time kind of a scenario. That kind of experience she has. Tomorrow she will be spending time with a team member, Ramesh, who is also another the deep learning, machine learning architect, and both are going to be spending a good amount of time with you all with a real-time scenario. That is what actually very important for today's world. That's why we made this workshop as a 2 days workshop instead of 1 day. So what do you think? How it's going to be useful for you for next 2 days? Any comment or any suggestion? Anything you want to incorporate as part of that? Okay, silent. Okay, that's fine. Let me move on. So with this, I encourage all of you to spend good amount of time, concentrate on each and every one's presentation, and see how you can adopt these things in your career currently as well as in future. With this, I'd like to invite Dr. Farang to start our workshop. And I'm going to be here for some time. Certainly, you can interact with me, and even I want to have one more thing. I'm also teaching in University of California, San Diego, the data science as well as the chip design, and also there are opportunities for students from here to learn about some of the things happening in UCST, as well as I'm also going to provide international internship and international travel tours and all those stuff. If you guys are interested in it, please do talk to your HOD, Dr. Vincent, and we can work out on a plan too. And that's a great opportunity for you guys, to visit while you are in the college, and nobody, would get easily, that kind of opportunities there. Okay. So with this, I'm going to hand over the session to Frank, and it's going to be a good one for you to, next 2 days, just observe it and see how you can deploy it. Thank you very much. Thank you.
It's time to honor our chief guest by presenting a token of appreciation. I would like to invite Dr. A. Vincent Anthony Kumar, Sir, Professor and Head, Department of IT, to honor Mr. Farang Yajdani, Sir, and Mr. Ganesan Naranaswami. Sir, kindly. And now I would like to invite Dr. Anandraj Sir, Professor, Department of IT, to honor Mr. Shivakumar Shanmugam Sir and Dr. Bhumeshwaran Sir. Now, I would like to call upon Dr. Babu Sir, Professor, Department of IT, to honor Mr. Niranjan Kumar Sir. I would like to call upon Mrs. A. Sangeeta, Department of IT, to honor Ms. Shri Kamni Ma'am. Ma'am, kindly. And Dr. Pradeepa Ma'am, Department of IT, to honor Mr. Nagraj Trivedi Sir.
Mr. Farang Yazdani, our esteemed guest, Mr. Yazdani is a distinguished professional currently serving as the President and Chief Technology Officer at Broad Park Corporation. With a comprehensive educational background, he completed his studies at the University of Washington, showcasing a strong foundation for his exemplary career. As a visionary leader in the technology sector, Mr. Yazdani brings a wealth of experience and expertise to our event. His role at Broad Park Corporation reflects his commitment to innovation, making him an ideal speaker to share valuable insights and perspectives with our audience. We are honored to have Mr. Farang Yazdani contribute his wealth of knowledge to our workshop. Now I invite you, sir, to enlighten the gathering on Gen AI in IoT applications. Sir, please.
Hi, everyone. It is exciting to be here. My first trip to India. Very exciting. It's an honor to be here. I would like to thank the committee for the invitation to be here. I'm here to talk about the AI. In fact, the hardware side of the AI. So, what we do as our organization, our focus is going to be on making the hardware for the next generation of the AI that is coming up. So why AI is so important? Because it's going to help us to determine the pattern in the data. So the data could be from the IT, could be some medical data, could be a CT scan, could be any type of the data. And those data most likely is going to come from some kind of a sensor. So the sensor technology is going to be very important. And that's the foundation of the IoT. So everything is going to have to be sensed. Some of the data is going to have to be collected. The data is going to have to be processed. And then, so you got the hardware aspect of the AI, and then you got the software side of the AI. So all of this infrastructure is going to have to go into place to determine and to extract the right information from the data. This is the age of the data processing. So now the question becomes, why AI is happening now? Well, AI is not a new thing. In fact, it's been around for so many years. And the reason that it's happening now, because it needs two ingredients to fuel it. One is the data, and the other one is the computing power. So at this day and age, we've got enough data, and then we've got enough, hardware to be able to compute. And that's why we see that the data is happening now. Now, how you process the data equally is going to be important. If it's on the drone, or if it's on a space mission, so that the energy conservation and then how you process it is going to be very important. So the need for the ultra-low power computing is going to be super important, because energy is essentially everything. So my presentation, some of the things that I will talk about is going to be focused on what is coming up on the hardware side of the business. How are we going to make the platform so that when the data comes in, we can do the processing and then tell you what the data is, and then allow the software to actually access the hardware. So there are two key elements here. One is the circuit, or the key processor itself, and then two is going to be the memory. So this is the so-called the memory and the logic. And then how we're going to integrate those is going to matter, because that's going to impact the form factor, how large, how small, and the computational efficiency that's going to be needed. So just to give you some idea, some background. So my talk could be a bit technical as well, which might give some idea how things are happening and how the industry is changing the way we've been doing. So the first thing is to understand the market trend, the mega trend that is changing the market, and then how the hardware is going to have to adapt to meet those two requirements. So I would like to talk about those based on the workload that we get at our company, basically. And then I'm going to talk about how we're going to pack all of those components to interact with each other, which we call it semiconductor packages. Many chips, we're going to integrate together into one component, which we call it the package. So the package is super critical. Why? Because it's going to determine, one, the cost of the product. Two, is going to determine the performance of the chip. And third is going to determine the form factor, how thin, how large, how small it is. And all of those are going to be very important depending how you want to integrate and then to put it into use. And third, I want to talk about some of the new technologies that is coming up, which is going to help us to achieve our goal, meaning to make it very simple to pack more functionality and more chip into the same package. That's going to be important. That's what we call it, the emerging wafer level package. And then at the same time, I also want to talk about how are we going to stack these chips on the top of each other, or the so-called 3D stacking or the 3D heterogeneous integration, because every chip does some functionality. It could be the different material, could carry the different circuits, and then how we stack it is going to be important. And there are many challenges in there. I'll talk about our involvement with the DARPA, the head of the U.S. agency that funds this type of projects, and the type of the work that is being done to achieve the 3D HI. And then I'm going to do a quick summary of that, and then I'm going to open up to the questions and the answer, and it's best when we interact and we talk about it. So here is the mega trend. As a design house, we more or less have a good, idea where the market is headed, depending on the workload and some of the requirements. So as you can see from right here, most of the work is focused on the advanced edge computing and the cloud. And it's going to be multi-die in the memory and the logic. That's where the focus is. And why is that? Because that's the backbone for the AI. AI is going to need a lot of, obviously, memory, a lot of dies to pack it together and then to packages. That's going to be important. And the way we've been in the industry is also changing. I mean, if you look at the pattern, the way that the chip has been designed historically, it's been a single die, a single chip that does many functions. But that has changed. So because of the cost, because of the functionality, in the yield, all of those, what is happening is that a single chip is being partitioned into smaller chips, which we call it the chiplet. And we're going to reconnect those small chiplets with a high bandwidth interface that they can communicate to each other. That's where we're heading. So now you have more chips, or the smaller chips, with the high bandwidth interface that are going to have to talk to each other. And now you're going to have to package and then put them on the same substrate or the PCB that they're going to have to talk to each other. That was the bulk of the focus. And as you can see, there's an image from the IBM that shows actually many of the chiplets. You can see the 3D, you can see the 2D. Some of these things are talking to each other. You can see communicating with the passives on this is called the substrate, when all the chips are sitting on a substrate. In fact, in this thing, you see that multi-chips are sitting in what is called a silicon interposer, which is a finer type of substrate that is going to help to connect the devices to each other. And then this interposer is going to sit on a piece of PCB, which we call it the organic substrate. So job. So what the package does is going to take very fine pitch, bump pitch, or the signal from the die, and it's going to fan it out to a coarser bump pitch, which you call it the BJ ball. And now this component, you can test it, you can verify it, and you can qualify it, and then you can put it on a PCB so that multiple of this component, they can talk to each other to build the backbone of let's say, some IT processing. As I understand, so many of you are into the IT, and well, the data is coming from the IT. How are you going to process it? That's how it's going to get processed, and this is what is going to have to be architected, and this is what is going to have to be built and manufactured. That's where the idea is. The second area, which is right next to this, is the photonics, silicon photonics, or the photonic chiplets with some kind of a standard that's going to help us. That means the industry couldn't wait. The electrical communication was so slow that, well, they decided to use the light to communicate the data between the chips and the components. And to do that, you're going to need an optical I/O. That means a type of input-output I/O on a chip that can take the light, process it, convert it into the electrical signal, and feed it into the circuit on the chip, and it gets processed. So now is the era of the optical I/O. Things have changed. The industry is moving very fast. That means now we are able to build a super fast platform for the amount of the data that comes in to get processed with light. In fact, the chips of the future that is coming up, instead of the electrical, is going to be light. It's going to be optical chip, right? And that's the next wave of the future. Again, the industry couldn't wait. The things are processing so fast that the electrical and the copper and the way things be done is just way too slow for us. So now we're talking about the optical, or the so-called photonic packaging, that we're going to have to build and manufacture and to enable that. Here's an image, one from the Intel, that you can see. You got a die or a chip which is a network processor, most likely used for some kind of an IT, that is sitting there. And on the periphery, you can see these are small, tiny modules. And what those modules are is got photonic chiplets that's going to take the optical I/O, and these are, in fact, the fiber. You see, these are the optical fiber that connects to the package. So the light comes into the 800G module that would convert it to the electrical, and then from the electrical interface is going to get connected to the main chip for the processing. This is the backbone of the communication. Now, as we're speaking, things are going to change. That this chip itself, instead of being the electrical, is going to be the optical die. That means everything is going to be done in the optics, especially for the AI, for the multiplication of the matrix, which is called the MAC. So the MAC of the future for the AI is going to be optical chips. All right. And then how you package and integrate those optical chips is different than the way we do these things. So you might have external, laser that is going to have to be aligned precisely with the precise number of the channel to get coupled into the optical chip. And then there on, you might have a CMOS chip that would get that data and to do its own thing. So the other area of importance is going to be the automotive and the power devices, which is going to depend on the silicon carbide as the chip material. That's another area very important. So the auto industry and all of those high power are going to depend on this thing, and we see quite a bit of attraction here as well. And then, of course, the 5G, 6G that Ganesh just mentioned, right? Those are the ones for the communication, and we have expert speaker here that are going to talk about it more. But these are used, again, for the communications, etc., 5G, 6G. And then fog computing. Fog was something that was sitting between the edge and the cloud, that we see less of the traction. We see more of either you're strictly on the edge computing, that means where the device, where the component is, I want to process the data here, I want to understand it, and I want to make a decision right here, rather than to go on the cloud. What's happening on the cloud processing is going to be for the training of the data. So now you've got this massive amount of the data that coming in, that those are going to have to be tagged, they're going to have to process, and they're going to have to be trained for the AI. And for that, you're going to need massive amount of processing, CPU, obviously GPUs, or the memory. And that's what is happening in terms of the hardware and the platform that is going to need it to process the AI. So now let's talking about some of the technical aspect of this thing, that how we're going to cram more chip into a smaller component that meets the form factor, and then of course meets the thermal management of the chip. Every chip is going to create heat, so you're going to have to maintain the threshold, the temperature to some limit for the chip to operate. If it gets too hot, it's going to kill it. So we need thermal management, strategy in place to manage these things. So to pack more chip, or the memory and the logic, into a package for the AI processing, we're going to need good substrate, or the PCB, that we can mount the chip onto. That's going to be important. A lot of work and technology going on right here to build this thing, how to make it more accessible and to pack more with higher chip density. And then, of course, we're going to have multi-die. I talked about the chiplets. So you got many chiplets, now you're going to pack it together. So the tools, the equipment, what they call it, the assembly process, how it's going to pick every chip and it's going to align it and it's going to put it right on the substrate. This process is called the assembly process. And then, of course, once you've done this thing, now you're going to have to test it. Now, if one of the chips doesn't work, then the whole thing is complete waste. So the testing is going to be very important, and how we plan for the test. Of course, scalability. So every application has got its own, obviously, demand. How can we add more function, and how we can scale it up as we need it? So the plan for scalability is going to be very important. Of course, the performance. So the AI processing is all about the performance and the efficiency here. So that means both in terms of the electrical, in terms of the thermal, as well as the reliability. So the reliability of this is going to be super important. Because if it doesn't, after we do all of these things, means if we meet all the electrical, the thermal, and all of the expenses, all of that, if it doesn't qualify, which we call it the qualification process, then it's a complete waste. We wasted multi-million dollars, and the part cannot go to the market or to go to the server to be used for that. So that topic by itself is a whole beast. We're going to get into some more detail and discussion about the reliability of this thing. And then, of course, the stacking. So now you say, well, I can stack two chips right next to each other, or I can stack it on the top of each other. So the 3D stacking has got its own challenges, but again, it's got its own, obviously, benefit as well. For one thing, it's going to shorten the communication between the two chips, right? If they're stacked on the top of each other, they can talk in the Z direction rather than in the XY or the planar. So this is where the push is right now, really to pack more chip of different material, different functionality, test it, and then we're going to stack it. And now we've got a loop going on in 3D that we can process the data. Maybe the top die could be a sensor that can actually sense the data, go to the below level to get obviously processed, conditioned, and then to go out. So the market has changed. So the advanced edge computing and the optics. So the modern packaging is going to require all of these things. It is getting very complicated. It's a noisy world. This is where the challenge is. Now, I was talking about the stacking and packing more chips, talking to each other. And what it shows here is the roadmap of how things has actually evolved and has changed. I bet many of you guys are doing IT and you're accessing the server or your, I would say, hardware probably is got some form of this type of chip and the component it is. And this shows that starting from a single chip on a package, how it has changed to multi-chip in 3D and 2D. And then we went to a single die in other form of processing, which is called the fan-out. And then we use other type of communication here for the chiplets. And then now, this is where the focus is. For those of you who are focusing, or the faculty members are doing the, obviously, research, this is the area that has a lot of attractions because of the complexity that is involved when you go to 3D, whether it's the material, whether it's the I/O, the communication protocols, the thermal management, the mechanical aspect of it, all of that is a good area of the research and is actively ongoing here. So the question is, why the change? What is changing the transformation in the packaging? Well, of course, we talked about it that we don't want to pack everything into a single chip because of the yield and the cost and essentially all of this. So if we are doing multi-chip, if we are partitioning a single chip into a multi-die fashion, we want to have the same performance as if they were a single chip. This is what we call it the near monolithic, right? That means the 4 chip talking to each other, the performance I would like to be the same as a single chip. That's the whole idea. So again, this type of terminology, it is fueled by the rapid change in the megatrend, and that was the AI processing that I just talked about. So the memory, the logic, obviously bandwidth, and the photonic and the CMOS integration. These are going to create the infrastructure so that it is near monolithic performance. And the 3D HI, or the 3D heterogeneous type integration, multiple components, different functionality, is causing this change, how we integrate. And then the foundation of this hardware is the substrate. And the substrate is going to its own requirement. That means the traces that we route and connect the signal should be very fine. We're expecting less than, I would say, 1 micron line within spacing. It should support many, I would say requirement, as you can see here. It should be thermally conductive so that we can manage the heat. It should have a good electrical, I would say, performance right here that we're talking about here. And we should be able to test it in a modular, step. So the requirement has increased, the functionality has increased, and those are the challenges. So now you decide to stack. Now you stack and you've decided to put few chips on the top of each other. Looks great, but not that easy. There is more into this thing. Obviously, everything that we do is multi-die, multi-discipline, multi-material, right? One of them could be a device that is doing some medical, AI processing, or it could be some memory, or any of these things. The failure mode is going to be important and is very complex. This is what they call it, like the domino effect. That means if one of the dies, one of the chips in the 3D stacks fail, the whole thing is a wasted. So the complex failure mode for the 3D, that's a lot of effort on going into this thing. So the requirement. So if you're building this hardware for the AI, what are the requirements? So you want to stack it. The performance is going to have to be superior performance, both in terms of the electrical. Again, we're going to have coexistence with previous dies, and then these are called the chiplets, or the smaller dies that I just talked about, right? That are connected and with interface, that they kind of talk to each other. So the coexistence of multiple technologies from multiple fabs is going to be important. And then, of course, the heat. We're going to have to manage heat, and then how we test it again, and the reliability. So to build this 3D stack of the hardware for the AI, we're going to have to meet, all of these things, at least. These are the bare, I would say, minimum, right? And then I didn't talk about the cost, which is another thing, right? So here's an example that if you had to build a hardware, basically, for an AI, a basic hardware, basically, for the AI processing, could be for the IoT or any type of application. It just varies the amount of the memory that you need and the type of the logic that you use to integrate those. So you may have different stack of some kind of a processor, and then you're going to have the memory chips that's going to sit right on the chip. And then they're going to communicate in the vertical direction. And this is a kind of a pretty good example of what do we mean by a 3D stacking of these things. So now we're going to have to optimize and to build this device for the AI. Again, some more in-depth, some more technical. This may not make sense, or it does make, I would say, make sense, but each chip is going to have to be designed and optimized within the dies in 2D as well as in the 3D. All 3D direction, optimization, and the design is going to have to be done. Here's an example of a chip that can be used for the AI, basically, right? So you got a core. This is where most of the processing for the AI could be done. And then you got the PLL, and then you got some other components, some of the, I would say, memories, and the other periphery that goes into chips. So I talked about some of the activities that is ongoing in the U.S. for example, with the DARPA, which is part of the Department of Commerce. That's kind of funds these type of activities, and to build something in 3D, they had to fund a few other projects previous to this thing, to get some experience, just to build the requirement before we can build in 3D. So the first, what is called, was the DAHI program, which was a different between chips with different materials. They had to be bonded, manufactured separately, and then to bond it together, and to figure it out how to do that, basically. So as you can see, you got different chip with different material actually bonded at the interface and fused together just to build that. Once that program was done, we said, now let's do the CHIPS program, which is the common heterogeneous integration IP reuse strategy. And our company, we are actually lucky to be funded along with two other participants, got funded just to work in this area at the time, about 5 years ago. And what we did is that we worked with many other companies that they make these chips, and how to integrate these chips with the dies side by side. So these are the so-called chiplets, meaning smaller dies with a high bandwidth interface on it that they can talk to each other. So now you got many of those that you want to put it, assemble it so that they can talk to each other. That's what the focus is here, as you can see. So some of the chip could be a signal processing chip. Other one could be a radar chip. Other one would be a communication chip. All of these things, we want to talk to each other and to build a fully processing system on a package. Once this was completed and it was done, now there was enough experience and some data to be able to build the 3D HI. In this case, as you can see, this is from the DARPA. You got a processing chip right here that is sitting. You got the filter chip that is sitting here. You got the RF, the transceivers, and then you got the antenna layers, all of them being in a stack in 3D. Fully functional. So again, this is a good example of the complexity that the 3D is going to involve, but it's got its own benefit. Meaning a lot of your research and the work, and this is a very good example for the faculty members and the student, those who wants to focus in this area. This is the area of the research and work, and to focus on. I talked about the PCB, right? The piece of the substrate that you got the chip sitting on it. This is the backbone of this semiconductor industry, really, because that's going to determine your cost, the cost of the components. This is the major cost, because now you have to manufacture very fine line within spacing connections or the communications here. The technology that is emerging is taking something very coarse, is going to create something much more simpler, more functionality, and it's going to pack more connection into it. So this is the so-called wafer level, meaning from a 10 layer, it could come down to 4 layer. Considerable cost and the performance here. At the beginning of my talk, when I was talking, I talked about many types of integration, right? Like the 2Ds and the 3Ds and, a single fan out or the multi-die. Yes. All of these things is going to converge into a single component, right? So now we're going to make life a bit easier. And that's because of the new R&D and the technology that is being developed in this area, which is going to help to connect all of these chips together. This is the game changer. And once you have this, which is also thermally conductive, you can now do a much better job in stacking things. It's the same material as the chip itself. So it's going to behave a bit better than the conventional way. So with that, I'm just going to kind of give a good summary of what I've talked about, and I'm sure we want to spend some time to interact and talk about it. So the key for the AI, whether it's the generative or the deep learning or any type of the AI, is going to be the ultra low power processor, the computing that has to be designed for the IoT application or any type of application you want to do. We're going to emerge into a chiplet era. That means, again, partitioning a big chip into a smaller dies that we can reconnect them and then package them. This is again super important. The emerging substrate that I just showed a few slides ago it has emerged as a game changer, which is going to help superior RF performance. And that this type of substrate is also going to give you the density that you need to connect all of these dies together. And then it is going to enable the photonics and the silicon and photonic integration. Again, very important. And again, it's going to have to help with the modular testing as well, because now you can pack more devices into a single component. We can test each of these components and then build a larger system around it. So that kind of ends my talk, I think, right here. And I'm going to open up to questions or any other exchange that they might have. I would like to thank you for the time. Thank you. So let's start with the questions.
Students can raise your questions to sir.
Well, I hope it did make some sense, right? Because all we're doing here is building the hardware for the AI. And at least you've got some idea what it's going to take to build the hardware that is going to be needed. Sure.
Just let me start with the question. So you talked about processor, like CPU. How in the with the current technology with high performance servers, right? I mean, especially gigabytes, terabytes of data. When we talk about the GPUs, right? So how do things what you showed here refers to the GPU technology?
I'll say it again. How did it get?
What you showed in the chips, these chips, right?
Yeah.
These chips can be applicable to GPU also.
Of course, the chiplets. I mean, if you look at, I would say NVIDIA, for example, right? If you look at specifically like the Grasshopper, one of the product, right? So that got the ARM processor, and then you got the GPU. So the GPU, CPU both combine into a single package, right? So you can have the GPU, all of them lined up for the parallel processing, or you can have the GPU, CPU combination, as what they've done in the Grasshopper, with the high bandwidth, I would say, memory. So that's all about what we call it the heterogeneous integration. That's where we're heading. That means we can pick and package the best in class for the certain application. And
I think you brought up a very good point on the IoT devices. Maybe I would like to give you a presentation and show you that exactly what we use with the track and trailers.
perfect. Perfect. Yep. Same. Yep.
So good morning, sir. So when we want to bring AI for IoT applications, what are the processes we can go for?
Well, again, you're just going to have to see what your requirement is, because every chip design or planning is going to start with the spec or the specification, right? So that's something that is going to have to go in place first. That means, say, what is it that I want this chip to do, right? What are my specifications? So you start with the spec, and then of course it's going to involve how to translate those specs into a code, into the RTL. The Ganesh and the team, they can talk about it more, and that's the front end. I mean, in the front end, that you convert that, and then we're going to synthesize that into the hardware, that we can actually build the actual hardware that does, that meets your spec. So first we're going to have to establish what the spec is, whether it's the, and what needs to be done. That's correct. Yeah. Now the sensor technology is going to be equally important, because that's going to enable you how to collect and extract the, to extract the data. Could be for the biological, could be for gas, could be for anything. So focus on sensor technology is going to be super important and critical. All right. Okay. I think we're done.
Thank you, sir, for such an informative session highlighting the role of Gen AI in IoT applications. Now I invite Mrs. S.T. Bharati, ma'am, Professor, Department of IT, to express gratitude by presenting a token of appreciation to our esteemed chief guest, Mr. Farhang Yazdani.
Honored to have Mr. Shivakumar Shanmugam contribute his wealth of knowledge on Gen AI in logistics to our workshop. Welcome you, sir. The podium is yours.
Thank you. Thank you so much, PSNA. Good morning, good afternoon, or whatever the based on timing. And I'm truly honored, humbled, and excited to be here. And thanks to the PSNA management team, Dr. Vincent, and my old friend Ganesh, to bring me here and just to give an idea about talk on the logistics, Gen AI, right? So I was told, I was just talking to Dr. Hemalata, HOD, I see like a lot of folks from different branches, right? Mechanical, civil, electrical, and all the combos sitting here. And my strong recommendation is when you go for jumping into data science and AI, it's not applicable to only computer science or particular AI, right? It's applicable to all the branches. So I will show you some scenarios, what we use in logistics. And when you talk about logistics, like trucks, as you see in India, you see trucks. Just to give an idea, do you guys know an average truck driver, right? We have truck drivers in US. You know how much he makes per month? Any idea? Like a salary, right? I'm just taking a salary, right? Yeah, average truck driver, you take him, he drives 4 days a week. Average 4 days a week. You know what is his income? Just guess. So at the minimum, he makes 6,000 US dollars, which is equivalent to 4.8 lakhs, right? So that is the beauty about, it's not like it's ordinary job, it's a hectic job. Driving Texas in the US, driving across east to west, north to south. We have it's a hectic job, but they make that's amount of money they make. And so you know that, right? You for example, you take in truck driving in India, when you compare to US, that's a kind of I'm just showing that difference, what they make and what we make here. And one of the biggest thing in US, why the trucking industry is so important is, whatever the manufacturing things they make in one area, for example, in Dindukal, you make milk, right? For example, milk is produced in one place, that's shipped to inside the area quickly, right? On board, I mean, the same day. Whereas in US, milk will be produced in California, and then they have to ship the product to East Coast, that's the New York. And all the products, not only milk, all the producers, vegetables, all the, including the construction equipment, everything will be getting shipped from one location to another location. So trucking is one of the biggest business in US, and I will show you some of the, what are the revenue we produce in our company. That will give you some excitement, right? What is the industry and how it's growing up. All right. So I've just put together a small agenda. This is just I prepared during my flight from US. I just landed last night, and apologies for me if I do something different. Sorry, I'm still going through some jet lag. So the agenda is I'm going to talk about our company, the Werner Logistics, and just to give an idea, I know I was talking to Dr. Yamalata, and you all know about Gen AI and the concepts, but I just want to cover from my understanding a little bit, like basic things, right? What is the AI, ML, and deep learning, along with what the heck this Gen AI is doing. And then we'll cover into some machine learning types and what are the steps involved, and go to the traditional versus database machine learning. And I want to show you a scenario where we use this truck data, basically in the logistics, how the data is getting used and how we do some predictive analysis. It will kind of, just excite you. And again, you don't need to be a hardcore computer engineer or data science or this thing. You can be any engineering branch. You can use this, the techniques. And one thing I just want to cover is demo. With regard to demo, that sensor data demo, I think tomorrow, Ms. Kamini, they're going to cover a hands-on lab. Some of the things you'll be seeing in the hands-on, what they're doing, how we are predicting this data from pandas to, from the algorithm, how we are predicting, which is, predicting, and then we do, I don't know, whether we cover some confusion matrix to show how close that algorithm is compared to that test, the trained data set. So it's not working. With our company, right? So Werner Enterprises. So about Werner, we are one of the largest carrier in Midwest America. And our headquarters is sitting in Omaha, Nebraska. If you look at US map, right, the bigger map, if you look at this, put the central location, that's Omaha. And right now we are operating across from US to Canada and Mexico. So our tractors, whatever we own, tractors go take the goods from US to Mexico and Canada and all over the US east, west, and south and north zones, the various zones. So just look at the company history and just want to excite you, right? I mean, our company started way back in 1956 with our owner is called C.L. Werner. He started with loaning his truck, right? Loaning his truck, and he bought a tractor and trailer. And he started the business in 1956. So at the time, he was owning only one truck, and today, so this is 1956, he got the one truck, right? He was started driving, and it went all the way to reaching $1 billion. See this? In 1999, we reached our business to $1 billion. So $1 billion is equivalent to, for example, 7,500 crores rupees, right? So that's where we reached 1 billion here. And here from 1998, it goes all the way. Here in 2020, right now we are at 3.3 billion, which is equivalent to 30,000 Indian rupees, right? And all the way, with the one person we started, and we went on to NASDAQ, right? Even though it's company-owned business, we went to public way back in 1990. And then our court is won, which is running through the public company, and which is, go through the process. So if you look at the thing, what we did from 2000, it took almost 50 years to reach $1 billion. And if you look at from 1 billion to 2.3, it took only 15 years. So there are a lot of changes happening, right? I mean, so you may be wondering, what did we do to reach this thing? And somewhere you see that edge, Werner edge. That's our edge computing, right? So which is, we'll talk, I'll give you some detail on there, and also I'll talk about, Professor Franks talked about IoT devices. So how these IoT devices fit in the tractor and trailers, and how it's getting used in the, trucks. So this is a simple picture, right? So what do you see? You see all the dots. So what do you think? This is the US map. You see all the lights. So what you see here, the lights is nothing but our tractor locations. So all the trucks are fitted with a Qualcomm unit, and it sends ping data, right? Continuously we get ping data from trucks, and we collect those data into our mainframe on the AS1 system, and continuously visualize where our tractor locations. So if you look at this, for example, a picture in this area, right? I mean, see this is Florida. You see heavy volume here. See all this New York heavy volume. And in Texas, this is Texas heavy volume, right? And when you go here north, you don't see much. And this is a single instant. And this is we continuously monitor. And our strength is 8,000 trucks. Right now we have 8,000 trucks and 35,000 trailers. The trucks is the power unit, and trailers are the connected units which haul the load. And we have flatbed trucks, temperature control trucks, flatbed trailer, temperature control, and then a van, which is nothing but the covered trailers. So all these trailers will take the goods from, for example, one location. We talk to the shippers, right? Shippers and consignee take that order and then take the item from one location to another location based on that the routing. So one interesting point, if you look at the picture, when you want to haul the load from one point to another point, the interesting point coming to picture is which is the best route, which is very, very crucial for us, basically. So to choose a route, we have a kind of a route optimization process. We have a PC mailer system we have connected. So it gives us which you can think of as Gen AI, right? It's kind of continuously updated. There's a generative AI sitting there. So if we give us target origin and target locations, it goes through the point and gives us the various, you can go take this route. So based on that, we ship the items to get it to the consignee with less price. We also don't want to lose the money during the shipment. Try to find out shortest movement path, and with efficient move, and with also considering so many factors. There are so many factors involved here. There's a weather conditions. We continuously monitor the weather predictions. Something happens during that move, something blocks, immediately it should alert to the driver. And all the trucks are fitted with edge devices, edge computing device, and which constantly send the monitoring from our main system, So this is the kind of interesting fact. And one thing I want to point out here is, if you look at this, see that from Texas, we go with this route, we go to Mexico, right? This is the entry point to Mexico. And from north, when you go to Canada, from New York, this is the New York state, from here you go to Canada. And this doesn't show the location of trucks in Canada and Mexico because of proprietary the reasons. And we collect only the continuous data set and show anytime where the truck is moving and what's happening. So that's kind of an interesting thing. And we look at the volume, right? The ping data from a tractor is coming every 15 minutes. Ping the data. See, the volume of data is so huge. And we have a special process to cleanse the data, continuously, the real-time data coming in. We cleanse the data, process it, and feed it to a geographical system where it shows the lat and long and the tractor number. And immediately, using the tractor, the latitude, longitude, we do a geocode the truck and show it on the map. So that's how the map is visible in this scenario. So if you look at just one, as I said, our company is right now we stand at $3.3 billion, which is 25,000 crores rupees. That's a revenue per year. And our company plan is to reach 5 billion, this is 40,000 crores by the end of 2025. How is it possible, right? So this is where, guys, I'm not going to make it like a big thing here. This is where the point of Gen AI, machine learning, these are all we are going to use. And one question during the discussion you might ask, by using Gen AI and machine learning, what will happen to the employee strength, right? Because we have like one thing, I'll cover the next slide. Our employment ratio is 10,000 drivers, 10,000 trucks, 10,000 drivers. And we have like 2,500 office employees, like IT employees managing them. Now the question is, when we introduce these Gen AI and data science algorithm in trucking industry, so we are taking away the job from human being, right? Human jobs, you may be thinking that human jobs are going to take out and the computer will be doing the job, which in this scenario is not true. We are going to increase the employment. It's not like we are reducing. We are going to make more and more employment based on the skill set and this thing. That's how we grow. So far, I'm with this company for the last 20 years. So far, I didn't see a single layoffs. Even the recession time, we never laid off any people because we want to keep the talent with the company and along with grow by adding more and more talented people. So what I'm trying to say is data science is going to rule the world in next 20-25 years. Believe me, this is, I will show you the next slide, what will happen to the data science job scenario, which will kind of excite you. All right, so the path we are taking to reach this scenario, right, this 5 billion by the end of the next year, which is kind of 25,000 crores to 40,000, this is 15,000 crores we have to make. We have to make the revenue, right, within 1 year. The path we are taking is, right now all our data center in our company, and Dr. Hemalata, thanks for bringing that GPU idea. The thought is we have an on-prem data center which hosts all the IBM servers and Windows servers, all the servers running on the server. So the problem is when we compute the huge data, right, the ping data coming along, I'm just giving an example, compute data, the CPU processor cannot handle. Now we need to go for bigger machines. So acquire bigger machines, that's going to be a big change. Even a single change in our environment is very, very good change. Also, as I said, we have a PC mailer, freight rater, rate the freight system. We use different application servers. So anytime when you make some changes to the application servers, it's going to be very expensive for us when it's sitting on-prem. So one of the biggest in the idea we are taking, biggest initiative we are taking is trying to move all the on-prem solution to cloud-based solution. So cloud is going to be a big thing for you guys, and I strongly recommend. I was told that you guys are taking some AWS certification and thoughts. Kindly look into AWS, Azure. These two things are going to rule the world. And I want you guys, everybody look into the concept of getting at least certified maybe Dr. Vincent, I mean, maybe with your college can sponsor some money or whatever. Try to, when you go out from the college, try to have one certification will boost your job scenario, getting job scenario. So kindly look into that certification path. So the path we are taking, so we are moving our on-prem to cloud architecture. So mastermind, which is nothing but a TMS, centralized TMS system, transportation management system, we acquired. This is a cloud-based TMS system running on cloud. And then we bought Salesforce, Workday, and those are the two systems. We are storing pricing, sales information, all the asset, right? What I told, all the asset information in that Salesforce cloud source. It's a cloud solution. Cloud, again, I'm saying like Azure is a database server. Salesforce is another server which stores, works with the pricing and sales information. And the Workday is all the company employee information. And then Snowflake is like a huge cloud-based data warehouse tool, right? And again, if you look at, and then coming to, we don't host AWS in our company because AWS is into retail, and we into retail, that is like a competitive vendor. So we don't, when we are looking at the product, we didn't go to the AWS, we went to Azure. But again, don't worry. Once you know one cloud solution, one database, switching from AWS to Azure or Azure to AWS is very, very easy once you have the thought process. And Azure, in the Azure, what we have is SQL DB and Cosmos DB. So SQL DB is a relational system, right? Relational database. So all the on-prem data, we are pushing to a SQL database in Azure. And Cosmos is holding the NoSQL. And I think, do you guys know NoSQL? It's like a JSON data, which will pump into that Cosmos database, and then we'll convert into relational architecture. And then one thing, as I said, the previous thing, so going from 35,000 crores, sorry, 25 crores to 25,000 crores to 40,000 crores, our management is strongly pushing into ChatGPT, Bing, Microsoft Bing and Copilot. We are using right now, Bing and Copilot is integrated in our software, and a chatbot. They are going to play a crucial role during this development and data integration process. So many jobs are going to be produced. And one thing I didn't mention is we have a strong offshore office in Chennai. And even though we have a US-based company, we have a group of employees who are sitting in Chennai and working from here as well. So there will be a lot of opportunities, right? I mean, if you are into these kind of concepts and ideas, you can easily jump onto this platform quickly. And another part we are taking is, so okay, the one more thing I said was, so I said, right, ChatGPT. So what does it do right now? For example, ChatGPT and Copilot, when you look at it, as a developer, application developer, all this time, you look at manuals, right? Manuals, and you start coding his codes and submit it to GitHub. GitHub is nothing but our the pipeline, the storage of the code in the system. Now with this Copilot, the Bing Copilot, what I'm talking about is, this is nothing but the interface. When you're developing the code, you run through the Copilot. Copilot, you say Copilot, right? It's nothing but when you're coding, it helps you. It's a pilot. He's sitting next to you and he's helping you to code the process. So it is nothing but a robo is coding that process. You don't need to think too much. So then now you can ask a question. Once if the robo Copilot is going to code, and if it is checked into the GitHub, what I'm doing, and as a developer, when you come to the company, what I'm doing, you are going to do a bigger thing. You won't be thinking in the smaller case. Yeah, I'm just looking at just from the basic stuff. You'll be looking at the advanced thing. How do you make this code for the betterment of work, right? So you won't be you don't think to. That's the thing. You'll be like when you work with Gen AI. The concept is somebody behind the screen, your brain. Somebody is using. You can help somebody's brain. So what is Gen AI? It's just another brain, right? We'll cover in the next slides. But it's just using another brain's thought process. It's helping you to think differently and code. Look more into the code-based the architecture. So that's kind of so. When people are talking Gen AI, is it going to take away a human job? Absolutely not. It's going to add more jobs. That's my 2 cents. And autonomous trucking, right? We see right now when I showed the US map, most of the trucks, 95% of the trucks are like manual trucks, right? With the gear and this thing. And we added like a 5% trucks. We are experimenting autonomous truck in Texas area, from Dallas to Houston, the pipeline, we're experimenting autonomous trucks. So what it is, autonomous when I mean, once you set that, you go to, like Tesla, right? Tesla, we have trucks also autonomous. So once you test origin and destination and give that map to the truck, it drives by itself. It moves the haul, and one person should stand in that Dallas to Houston is almost 300 miles. When it's miles, so 300 miles, it just drives by itself. And we tested and it is working. But the interesting point is, will it take away driver's job? Question, right? You'll ask the question, what will happen to drivers? But the thought process is, even though it's autonomous, we are not going to get rid of driver. There will be a driver sitting there, holding the steering, make sure that it doesn't cause any problem. So, no, our management clearly said, even though we are introducing autonomous, co-pilot, and all the Gen API, we are going to add more people, not like, getaway drivers. The driver has to be there. Even you think about a single incident, the truck get into accident, we lose millions of dollars for that, for the lawsuit. We spent a lot of money. That's why I will show you that the model what we built, how it's saving our trucks from the maintenance disasters. All right. So, okay. So this interesting point. Sorry. So we have 2,500 employees and 10,000 drivers, which is like 1-to-4 ratio, right? One employee will cover 4 drivers. So this is the I'm just collected from that US Bureau of Labor Statistics. Employment rate for data scientists will grow 36% in the next 5 years. So 36% is nothing but very huge. Among the IT people, that's the number it shows. So it should excite you, right? And excite you and trying to see that, what are the opportunities for data science. And I was told you guys are doing a lot of clubs and participate in different things. Those are things going to play in a bigger role when you go for interviews and attending, real-time jobs. That's going to be a, the big win for you guys. All right. Now that we covered this, just company info, I just want to, actually the company info is not in my agenda. I just want to talk about Gen AI. Just want to make you interested that trucking is nothing but, that's kind of the business we are running and what is that revenue it's producing. Just want to give you an idea. All right. So AI, ML, DL, and Gen AI. So you guys, already you guys are doing, that I don't want to cover detail, right? So when you look at artificial intelligence, that's a bigger picture. That's entire, right? You're making a computer. I might speak some basic things, but, be with me. Maybe it just recollects you with some other ideas. So the entire stuff, what we're trying to do is make a computer to behave like a human, right? That's the idea of the artificial intelligence. When you go to machine learning, again, that's a subset. The entire stuff of AI, within the machine learning, the AI, it's a subset of AI is machine learning, wherein we are just using algorithms to detect the patterns. We are using various algorithms to detect the patterns of large data set. We get the huge data sets. And what we are doing here is we are using two things. One is supervised and unsupervised learning. When supervised learning, we are using a labeled data sets. I'll cover that in detail. And when the unsupervised learning, data is not labeled. So the data is coming as it is. We go through a different cluster algorithm to break the data and then do that analysis, predictive analysis. Now, coming back to the next step, deep learning, right? Again, the deep learning, if you look at it, is again embedding with the machine learning, within the machine learning, where we're using a neural network. That's what I think next, some of the sessions, I saw that they're going to cover more detail on the deep learning and Gen AI. So I'm just saying that it's more like a neural network, and where we're talking about nodes, right? Nodes and how they're communicating with the nodes, and with the thresholds and different kind of pattern, where some of the deep learning process also go through the supervised learning too, right? Supervised and unsupervised, even though I'm saying that within the machine learning. And last portion is Gen AI, which is basing but nothing but content like text, images, and code based on the input data set. So just to understand from machine learning, I'm just going to cover the machine learning and the Gen AI. So machine learning, you can think of, for example, a dog, right? A dog's face. You are trying to teach a child, take a child and show a dog's picture. You keep showing the a picture to a child, keep on showing the dog, first time it doesn't understand. You show their eye is like this, nose is like this, and face, the lips, those things. You just showing the child, and then one time after keep on showing multiple times, what happens? It learns. Child is learning, right? And then finally, when you do, what is this? It says it's a dog. It's a cat, right? Or in another picture, cat. So that is kind of analogy we are doing in the machine learning process. Whereas in Gen AI, what you're doing is we're trying to teach the child how to draw the dog, which is a little bit complicated, right? First thing is just showing the picture and trying to recognize that's a pattern matching. That's exactly what we are doing with in the supervised and unsupervised learning. Whereas in Gen AI, you are just teaching the child how to draw a dog, how to draw a tiger, or whatever. That's more complicated, which child needs to first of all understand what it is, and then you need to use more complicated picture. That's where the complication starts, which is a very, very detailed thing. And the thing is, whenever whenever you look at Gen AI, people talk about big auditorium talks about it's kind of a boring sometimes. Hey, it's very deep. I don't understand. But believe me, once you start using this machine learning process and get into Gen AI, it's very easy. And the main thing we'll be doing is during the process is data engineering, the data cleansing process. That's where you spend more and more time to find out the pattern data. Once you find the pattern data set, pushing into the model building and predictive analysis, confusion matrix, that's all pretty straightforward. And one more thing, before I forget, one more thing is, I don't know how many of you are taking some statistics course. That's going to be a foundation for this data science. Please take a foundation. Be strong in some kind of a statistical course, which will help you for longer term. Make sure that you are kind of up to date. And before I forget, if you look at right now, right, and the reason in the past 5 years, if you look at in the US, and I was told, Dr. Vincent said you already have a AI and DS program here, and also AI and program is coming up. Now, if you look at the US in universities, every day, each and every, like University of San Diego, Texas Tech, University of Urbana-Champaign, your top university you take, right? Everywhere they start data science program. Every day I get an invitation, like we do a 6 months course, $6,000 or $10,000, you'll get a certificate. So the thought process is, believe me, that's a job market is very, very good for this program. And it doesn't matter mechanical engineering or civil, electrical, electronic, anything. Please take it like a very important thing. Along with your curriculum, try to take a small project. One of the interesting things is Kaggle. I don't know, I was told Kaggle is, the data set is not clean, or already clear data set you get, but there are Kaggle competitions are there. You can participate in the competitions, you make money. It's like a trading, right? Kaggle will open you that, give you a project and do the project and then make money. So the opportunities are there, abundant. Try to consider this, from that, as I showed, the job perspective. All right, so just to cover the machine learning types, as I said, just looking at the machine learning purely from machine learning, I have a supervised, unsupervised, where we have through supervised, because the data is already labeled, and setting it to the two types where we are classification and regression, two type kind of process we are doing. Whereas in unsupervised, we are clustering. Like for example, in the unsupervised coming to picture like a weather data, right? When data comes in, you are sending, move that based on the pattern, you are moving into a different clustering algorithm and predict what kind of weather it's going to be. This thing. Whereas in when the supervised learning, data is already labeled. You are working with a labeled trained data set, like a child showing that dog's face, right? You're showing the dog, and then that kind of training you are doing it in the supervised learning, and predicting that which is a dog or cat during that while building the model. All right. So now that we covered machine learning, if you look at the generative AI on the other side, right? Basically, when you look at machine learning, we saw supervised, unsupervised, and reinforced. These are the types. But when the data get fits to that Gen AI, it's at the right side. That's a picture. Right? This is what Gen AI looks like. So the thought process is, all this, what we are trying to do in this concept is, as I told earlier, you are making the child to draw the dogs, right? You're teaching the child. So how it's happening means it's a very complicated process. And right now, if you look at the Gen AI, the various Gen AI thought process, ChatGPT is one, ChatGPT 3.5, 3.4, sorry, 4.0, and Bing AI, which is nothing but Microsoft Cloud Copilot, which is the one, and Bard, which is Google. And right now, Google, as of last week, I believe as of last week, Google Bard is no more Bard. This is Gemini. They call it Gemini, which is the interesting thing I want to mention here is it recognizes images from the perspective. For example, right, somebody, you look at some people, I mean, your neighbor, you have a nice dress they're wearing. You go and ask them, hey, where did you buy? It looks nice, right? We talk, now you don't need to. You take the picture, you take a picture of that somebody's picture, feed into the Google Gemini, right? Yeah. And then what it does is, it goes back and find out what kind of clothes that dress is made up of, where did they buy, and what is the price. That's kind of a powerful things I was told that Gemini is doing, and then I believe ChatGPT 4 also doing the similar thing. So think about the thought is how much data it's looking at to do all this analysis, right? It's humongous. So in our Warner, what right now we are doing is we are using this. This is what we introduced the ChatGPT along with the Copilot. So what we are doing is all the developers, when they are building the code, it's hooked up with our GitHub architecture, and we get the code from GitHub, and while coding, it's basically is helping them to ease the code. It gives them when you're typing itself, the Copilot is helping them to code the code base. And then from there, we checked into that GitHub again to run the code. So complete automated process is happening through ChatGPT, Bing, and Bard, and that's where you are talking about all this the Gen AI is working on. And again, when you look at all the servers, right, behind the screen, they're all running on cloud. We don't have any on-prem system. These are all cloud-based system, which is cloud, which is a big thing. And behind the screen, as Dr. Farang was talking about, it's not CPU, it's a GPU. See, CPUs, you cannot work with CPUs, right? I mean, so there's a graphical processing unit fit in the system. There's a huge, very huge systems, and which does all this magic for you. And today, when you ask ChatGPT, any chat, I know you guys are using ChatGPTs and stuff. You ask any questions, it make the answer, structured answer, it gives you in a very structured way. What is the, and you need to ask the question in the right way, right? For example, ChatGPT is using all lingo. I mean, it accepts all kind of languages. If you have a mechanical engineering, you want to ask some typical to mechanical thing, it will answer that way. You cannot ask a computer science question, right? You don't know how to ask. So you have to be asked the right questions to get that right answer from that, this thing. And as I said, in the trucking industry, we use this, started using this one. And then second one, in the AI we are using is a Zoom. I know you guys are Zoom, you do use Zoom for chatting. It's like a chatting application, right? So what this is, any company meetings and any stand-ups or what we do, we use Zoom, which is kind of a online video call. So now the Zoom opened AI, open platform. So when you click the meeting, when you start the meeting, there's it opens the AI enabled. So once you open the AI, which is nothing but a Gen AI. So what it does is, you go through the meeting, like 10 people are talking to each other, right, in the meeting, 1 hour. As soon as the meeting is ended, when you enable Gen AI, meeting is ended, immediately you get an email, which is nothing but what did all the people talked in the meeting in the concise report. Not like what they talked in it refactors the data, whatever we talk, text through NLP algorithm, it refactors and brings the data in the concise manner. These are the things done, and what was the agenda discussed, and what was the result from the meeting. Amazing. So that's we started using this Gen AI so that it replaces some of the manual, documentation done by other employees. I mean, All right. This is about logistics, guys. I mean, as I was telling, this is the core I was telling, right? The AI. We started using it in 4 different ways. First thing is the shipments, or to find out the right correct route from point A to point B. So we feed the data, all the Gen AI data into this, all the routes into this our AI algorithm. And when we give the origin and destination zip code, we call zip code and origin city and destination city code, it gives it immediately, boom, it gives that origin destination, and then we take the route. And the second point is the final mile delivery, right? Once the load gets delivered, we have another system called final mile, which is nothing but the final load. Once the load delivers to home, we take the load and deliver directly to home. That also tracks our going through the Gen AI. And here, this one is shipment building. So we call, like, based on the packages we get, we call full truckload, and different kind of a pattern we are loading the trucks. So there also say that how many packages can fit in that particular trailer, right? So that's optimization need to be done. So we call the Gen AI and use that drone. And then last portion is that edge computing, which I was talking about. Each driver has given an iPad out. We call it edge computing this thing, and they use that entire stuff throughout that journey, from origin to destination. For that, whenever the load is getting delayed, or somebody is if there is any issue with that load processing, or if suppose driver is quitting in between, we need to find another driver to haul the load, and then load is reaching the right time, and whether you name it, right? Everything is going through this edge computing software. And behind everything is our Gen AI algorithm sitting there. All right, now fun thing, right? So I talked about data science and supervised learning and unsupervised learning. So if you look at the entire path in this, while building the model, right, you work with the Pandas, NumPy, TensorFlow. There are a lot of softwares. I mean, you might have used in this thing to cleanse the data, to format the data, and then run through a particular algorithm and to do some predicting. You might have used this kind of a tedious process, I was told, like you can use. Now, I just show you a simple methodology where it will interest you, right? It will take you to a different world. I mean, how quickly you can do predict the analysis. And take this as an example. And this particular thing, what I'm showing, you can do it in your computer, in your laptop. You can install, it's all open source software available, you can install it. How quickly you can basically just look at the data and then do some prediction. And with this example, you can go back to Google and other competitive products, offload the data, and you can do, you can understand how quickly it works. So what I'm showing is, this is called in-database machine learning, right? So what is in database? So what is database, first of all? Database is nothing but stores the data, right? So we have a huge data warehouse in our system. It's a huge data warehouse, right? For example, when I'm saying all the tractor data, ping data, the Qualcomm data, getting from our tractor location, right? They're all feeding into a centralized repository of a database. When I'm talking about tractor, one thing I just want to mention is our Dr. Frank covered about IoT device, right? He talked about IoT chip. So we use IoT device fit in a trailer. Trailers, all the trailers. So what it does is it tracks where the trailer is. So if you look at the tractor and you see in India, when you say truck is nothing but both are together, right? Our backs, power unit are together. There, front is power unit, back is trailer. Both are two different components, right? The power unit haul the trailer, and it will detach that trailer one place, and then it will go and haul the another trailer. That's how it works. Now, trailers not only hauled by tractors, it also hauled by train. We call it intermodal. For example, somebody is shipping an item from Australia to US. So the trailer component, right, the big trailer, it shipped from the ship through a shipment. It comes to the ship, come to California. That's our port of entry. We keep the product. Now, California to, for example, the shipment is to go from California to, for example, New York. Now, we won't haul directly from California to New York by truck. Again, we go and call the AI, give me that shortest path and optimized path. So you know what it will tell? It also does that AI is integrated with our UP, our Union Pacific train system. So we call the UP through an API call, put it on the train, all from point A to point B, and then part of the, based on that location, we all buy trucks. So what I mean by haul by train is, sometimes there will be like a temperature control products, right? For example, that item need to be, for example, I'm just giving an example, milk and frozen meat and vegetables, fresh vegetables, right? These has to be temperature controlled. So what we do, all our trailers that Expedia TC units are fitted with IoT device. So what is IoT? It's Internet of Things, right? It's IoT device. So what it does, I can track the temperature of the unit sitting in a central place, sitting in Nebraska, Omaha, Nebraska. So when for example, how the cooling system works is, it fit with there's a trailer. We have the gas, and it goes and pump the AC and then continues working. For example, if there is if it's during the hauling load during the train, suppose the temperature goes down, or temperature goes up, so my product will go bad. So immediately it sends an alert, from the IoT device, sends an alert to our fleet manager who is monitoring the system, and immediately goes back and he can turn on the knob from here, sitting here. He can throw turn on the knobs on the IoT device, and which will change the temperature to that correct temperature. That's a very, very, very interesting point. Well, I mean, one thing when you guys hearing chip design, IoT, and all these things, just put it in your mind. When somebody says IoT or chip, I mean, I know chips little bit fast subject, but try to understand how that is getting utilized, right? That will interest you. That way you can take that as a lesson, something you learn, go to that kind of next stage. So again, I said the IoT device is right now fitted with all the equipments in household equipments in US, name it. And it's automatically through IoT device. Any firmware upgrade, all the upgrades done remotely. Okay, coming back, I'll just go through I have got enough time, right? To do a lot of reports back to the management. Hey, this truck is in this location for so long. Somebody is not moving the load. Please go and talk to somebody. I'm just giving an example. So we do that data warehouse reporting. Now, one interesting question came in was, as I said earlier, we spend a lot of money for maintenance, right? For the truck's maintenance. If suppose the truck goes bad during the route, it goes bad, something happened to the equipment, we spend millions of dollars. Again, it doesn't go take the load to the right time. We spend more money, right? So with that thing in mind, we collaborated with the Ganesh team, and we set up a ML lab in University of Oregon. We set up a small lab running on a Linux system. We took a sample data set from take that sample data set, load it into a database, DB2 database, and I will show you in upcoming slides, and I'll just walk you through. So what we did, okay. So we call it like in-database machine learning. So when you look at that machine learning capabilities, right, from the data exploration, which is nothing but explore the data, how does the incoming data looks like, and the pre-processing, and model training, and model evaluation, and model deployment. These are the core components in the machine learning steps. So what I'm showing here is in each steps, right? Each box you have a list of processes. I'm showing like a static summary, visualize the frame, and a feature selection, and data frame operations. I was told, I mean, you guys are using pandas and NumPy and all these algorithms to produce this information, right? So what I'm going to show in the next few slides are how quickly you can do all these operations without moving the data from the database. Just sitting the data. I mean, in a traditional approach, we need to take the data outside the database in a CSV file or tables, send it to the NumPy or pandas, read the data, and explore the data from that. You use, I believe, Jupyter Notebook, right? Through a notebook, you use that all this process. So I will show you Entire stuff will be done by within the data. You're not moving the data anything, just do that analysis in the database itself. That's what I'm going to show you. So this is the setup running right now on the 11.5 running on that Oregon or machine learning laboratory. So we set up a database and we enabled that ML procedure. So IBM, what they did is with that latest fixpack, they introduced a set of algorithms, the IDAX functions. I call it's a procedures. They introduced, it's readily available. You don't need to shop anything going from outside. It's all sitting in that, within the database. So using this algorithm, I will show you the next slide. So the idea is, this is my truck running on the road, and I'm collecting a lot of from my engine, right? This is my engine. All the sensors continuously sending data. That's like a huge data set, continuously we're receiving. So what we do is we collect the data, send the data to the historical pipeline, and we have a storage unit where we store the data. And then what I want to know is, this truck in the route, does it need a maintenance or not? So you might have seen, right now when you're driving cars, you have already fitted with from engine light, right? It pops up. Whenever there is maintenance needs, engine pipe starts up. But our idea is, I don't want to see that on the route. I want to see that some kind of predictive analysis when the trucks start from the origin location. So what we do, the solution, what we did is, we collected this data set, right, into a DB2 database. That's a relational database. So continuously, all the data coming in. And I will show you, I don't know whether I have data. Okay, so this is the stuff. So in this case, we are doing a supervised learning. So what I'm showing in the top is the maintenance flag. And then look at all these components, right? What I'm showing here, the entire stuff. This is nothing but the feature data set. So in the real data science terminology, these are my independent variables, right? From the record ID to the region, these are independent variables. My dependent variables is maintenance flag, just like one thought process. So this data loaded into a database, DB2 database, we collected some data set, and I will show you the results set here next few screen. And this data includes the vibration, engine speed, what is the temperature, and then what is entire stuff, what we get from truck. So as I showed you in the machine learning, this if you use this one cheat sheet, you understand the concept, right? The entire stuff. So I showed you there are like 1, 2, 3, 4, 5, 6. There are 6 steps. Sorry about the names are. It says 4, 5, and 4. It's not 5. This is 1 through 6. There are 6 steps involved in that machine learning process. Everything is taken care by. Do you see here? Functions, stored procedures. This is the readily available stored procedures. So what we do, once the data is loaded into the database, I'm just calling a summary, IDAX summary, whatever the input table, boom, it will give you that number of rows in the table. You don't need to go to the pandas and heavy moving data set and then find out what it is inside. So you could directly, you get the data here. And again, when the split data, right, data transformation, what do we do? You split the data into a trained data set and a test data set, right? So again, the training data set is the one you're training, you're teaching the child how to recognize dog and cat, right? So what we do in the trained data set, you split in the, I'm showing a 0.95, is nothing but 95%. So 95% of the data will be like a trained data set, 5% will be go to the test data set. So here, out of 7,500 rows I have, 7,129 is the train, and then test data is 375. So this is the 7,129 rows of the data. I'm training the data to teach whether it's that particular based on the temperature, speed, and what are the various algorithm. I want to see whether the truck needs a maintenance or not. That's the label to label the system. So I train the data set, and what I do, this is again the naive base. When I say naive base, this is again IBM's stored procedure. Directly call that naive base. Boom, it builds the model. Don't need to worry about complicated process. Just just build the model, and it prints that model how it looks like. And then you print the model. It will print what are the probabilities and what is the 0 and 1. When you say 0 and 1, it's nothing but that a maintenance required or maintenance not required. And then this is the interesting thing, right? The predictive database. So here, what I'm doing in the model deployment phase, whatever that model I built, and I'm sending that the test data, 375 rows, right? I want to see how this looks in that in the model. So I'm sending this test data into the model and find out, and I built a predictive analysis here. Once I do the predictive analysis, I call the confusion matrix. So what confusion matrix does is, so initially I have 7,500 rows, which all the rows had a maintenance flag record yes or no. I labeled the data set. I split the data into splitting into train and test data set. Now I'm taking the test data set into that model and tell me, what do you know? I'm not passing that label here. Label whatever, I'm cut down the label. I'm asking the model, tell me in this model, what did you find out for that maintenance record or not? So I came with that result on that on the right side, on that confusion matrix. So what I'm trying to show here is, in this scenario, out of 375 test data rows I passed, there are only 61 rows came back and say that it's a different. Whatever the original prediction was not right here. So what I'm saying is a 16% difference. So my model is 84% accurate in this scenario. So this changes your mind, right? When you look at the complication process, I mean, how quickly you can run through that, model building and predictive analysis. And again, most of the time we spend time is that data cleansing, cleansing the data, right? And that's where data engineering, another job, booming up job. I'm telling you, data engineering job is more hot in the on US market. You can Google these things. Go to a good job market and think about data engineering, data scientists, and machine learning, developers. You see that number of job opportunities. So take this like a scenario and ask yourself next time when you get some data set, try to see, can you do this way? And to see that, how quickly you can build the model. And again, what you do is, when I showed a 16%, right? Now I want to make it like more accurate. This accuracy, I want to make the percent difference is only 2% or 3%. Accuracy means what I have to do. I have to collect more trained data set, train the model, keep on rebuilding, and then you will get that, bring down the number. And if I never seen 100% accurate, which is kind of, very, very huge thing. But at least you can bring down that percentage ratio so that your model, you can increase the accuracy of the model. All right, so these are I'm just exploring the tables, right? Whatever I stored in the table, the fleet database, and the test data, train data set, and then the count I'm doing within the database, just showing that how it looks like. And I think, Kamini, I don't know whether you're going to cover this tomorrow during any of sessions. Okay, if you need some help, let me know. I can zoom in and I can help you guys this thing. Okay. All right. So here is the only interesting thing, right? I mean, right now we took a small exercise. Now, again, I was talking to Hemalata. Sorry to bring your name. Thought processes, we need to ask more questions, right? Anytime when you given any scenarios, think differently. I mean, how do we outperform these data sets, right? So in our company, what we are doing in this scenario is, how long the truck can run without maintenance? That's a question. Now, how many drivers? We have 10,000 drivers. We keep hiring drivers every day. We hire 300 drivers. Drivers come and drivers quit. Now, based on the social data, we go to social network and find out what they're talking. Drivers are talking because the data set is available with us. Trying to see that, hey, what is his passion? What is he talking about? Is he going to quit the company in the next 30 days? If it is, we need to make sure do something different, make it to make sure that he's not quitting the company. And the company turnover in future, somebody manager or president next time when he asks, I want to see like next you reached 5 billion in 2025, but 2030, I want to reach another $10 billion, for example, turnover, right? Now, what needs to be done? Again, we are going back to Gen AI, ask the questions and do the analysis. And the accident prevention, and that's what I was talking about, the maintenance, right? And then battery life and weather alerts. So weather alerts, again, going to be a very, very crucial things for drivers when they're hauling the load to reroute the trips into different, this thing. And one more thing we are doing right now in the lab is, right now that this particular system is running on the Linux server, we are putting that in the AX OpenShift environment, and we are that process. We are still testing the process to see that how that's going to work in this work here. And these are the things, guys. I showed you that thing, right? I'm showing that all the procedures for the data transformation. These are the things IBM readily provides. So I'm just the data set, split data, standard normalization, all the things you can do with these functions. And explore the data, you can use these functions again. And model building, okay, as I said, IBM readily gives naive-based the decision trees you can do with this one. Linear regression, you can use this function. Naive-based, that's what we used for this for the lab. And then k-means clustering for k-means. So these are all readily available algorithms. And you cannot change it, right? This is readily provided by IBM. In case if you want to change the algorithm, Ms. Kamini, she's developing some kind of our own algorithms within our object area now, where we develop our Python code, right? We can go and play with the Python code and change that based on our requirement, and then use this as an algorithm. That's what's happening in our here. So these things you cannot change it. These are like purely given by IBM. And model tuning, prune duck tree, and then evaluation. We are using this to compare with that test data set with that trained data set. So how closely it matches, we use this. And in this exercise, we use confusion matrix, but we have other algorithms too. And then this model interface predicament, and then model management. And this is just a cheat sheet, guys. I mean, this is just, I'm talking about 3 quadrants: unsupervised learning, clustering, and dimension reduction, and supervised learning, and then supervised learning classification regression. Just like what's happening here. All right, that's all from my end. And usually, I can take questions. We can have questions. We can pose the questions later too. Usually, I want to end any kind of conversation with a small quote, right? Our Rajinikanth sir always tell a story at the end of the something, right? So one thing, as a student, I just want to bring this. Did you guys hear about? How many of you know Steve Jobs, who invented iPhone, right? All the phones we are sitting here is a Steve Jobs. His quote, one quote like with him is "Stay hungry and stay foolish." Do you guys know what it is? So I'll just give his lifestyle, right? Steve Jobs, he's like a multi-billion-dollar company on Mac operating system. Is when he passed away, he gave his wife $30 billion US dollars. Think about it. $30 billion is nothing but 30,000 crores rupees, some huge money, right? I was listening to his lifestyle, right? How he came up. So when he was born, Steve Jobs, when he was born, he born to a graduate mom. His mom is not even graduated. It's just a high school or, in US it happens, right? In high schools or in college, she delivered the baby, and she doesn't want to hold the baby. She wants to give the baby back to fostering. So what she did, she's looking for some foster moms, and she was looking for some fostering process. And somebody applied. They came and look Steve Jobs. They said, no, he's a boy. I want a girl. He's a boy. They rejected. And then she found another person. They came and saw the baby. And then they were not educated. So his mom want to give him to educated parents. So they said he's not educated, though she doesn't want to give the baby. Then they pursued her mom. Don't worry, we're not educated, but we'll make sure that your son is going to be educated. I'll guarantee it. That's how Steve Jobs' life started, guys. He went to a fostering home. Throughout his life, right, he basically gave the speech in one of the Stanford while addressing the graduation ceremony. What he said was, this is kind of mind-blowing. And then when he went to, his parents were poor, and he was struggling in life in his early life. He went to college. In the college, he stayed in a dorm. He doesn't have a bed. He slept on the floor. He eat only once in a day. He doesn't get enough food. And the only food this exact word he used. The only food he get, a good food meal he gets is In Sunday, he goes to a ISKCON, a Hare Krishna temple. That's where he get one good meal for him, right? That's kind of a struggle he went through. And then over time, during graduation, he dropped out of school. Again, he didn't graduate, he just dropped out of school. But what he did, he went and studied his favorite subject. He studied it. So they're like a calligraphy subject. And third phase he's talking about is, and he went on to started his own Mac iOS company, which is like a multi-billion dollars company. Then while working in the same company for some time, he used his own company, he got fired by the directors because of some other things didn't match. He got fired out. And then again, he started another company called Next is another company. And then he later returned back to Mac again. And the last statement was very, very interesting. What he said was, later part of his life, he was diagnosed with cancer, right? Cancer, and then it got fixed. He went through some process and it got fixed. And later, after 2 or 3 years, he was diagnosed again, and then he passed away. So one of the biggest statements he said was, always live in life thinking that this is the last day of your life, right? Today is the last day. What are the good things you can do? Do the good things. Then you won't have any problem about other things. So these quotes were very interesting. Why I'm bringing up is today in the US stock market, right? If you look at all the entire system, the Apple stock, there's this product stock. It's always, we look at the Apple stocks, all other trades, if you look at it, it's all just going, if the Apple price goes up, other stocks goes up, even including our company. Because that's the kind of company he built. And his past life was like that. So what I'm trying to say is, we all came from a good family. I mean, some of you may be struggling and all these things, going through that. Don't worry. Just follow those steps and you will achieve everything in your life. Thank you very much. Thank you. Any questions? And maybe, Ms. Common is here. Any questions later also you can point to her. Right now, if you have any questions, just let me know.
Okay. Thank you, sir, for your valuable insight about the integration of Gen AI in logistics and inspiring us to explore the intricacies of AWS and Azure Cloud Platform. Now, I would like to invite Mrs. Adi Lakshmi Ma'am, Department of Information Technology, to express the gratitude by presenting a token of Mr. Shivakumar Shanmugam, sir.
என்னை இறைவன் நன்றாக படைத்தனை தன்னை நன்றாய் தமிழ் செய்யுமாறு. Good afternoon, ladies and gentlemen, and the sprouts of the future. It's really happy to see here and be here. Appreciate the opportunity given to me. A special thanks to Mr. Raghuraman, the pro-chairman of this institution, and all the dignitaries and the resource persons who are present here and enlightening us with their abundant knowledge and experience. I want to put some disclaimers before I start the conversation. I would call it as a conversation because I would like to converse with you. I don't want to have this as a one-way communication, okay? So I want a real interactive session, and I want this session to be really useful to you and to me as well. I'm taking this as a learning curve for myself more than yourself, okay? So let us be as partners in this conversation. Will you agree with me? Yeah, that's the spirit. And before starting any further, I would like to make sure that the language is convenient and easy to understand. Or if you want to just switch over to your mother tongue or any other language preferences, let me know. I can very well switch over at any given point of time. English is only a tool, not a language. So you don't have to worry about it. So if you want to talk in Tamil, I'm happy with that. If you want to talk in Tanglish, more than happy with that. So, which one you are comfortable with? Boys, I am old, can't hear. So, will we go with Tanglish? Yes or no? Guys, I am hungry too. It's nearly 1 o'clock. I know, but just show some energy. Yes or no? Yeah, that's the spirit, guys. Right. The disclaimer I want to put it here is, I am not a techie guy. Got it? I don't know anything about engineering. I don't know anything about technology. I don't know anything about chip. I don't know anything about AI. So it is like me sitting with you, all right? no difference. But I'm the guy, the most important guy, who uses all this technology. And like Mr. Azani's enlightenment of how they are defragmenting the chips and making these chiplets is an information to me. And how the AI is interpreting their technology in the likes of logistics, the information given to us by Mr. Shivakumar is an enlightenment to me. Technically speaking, I'm not a big fan of technology in my younger days, okay? I'm an old guy, old school guy who loves to have hands-on experiences. That's why I took medicine, because I like to just play with human body more than the machines. But when I stepped into the fraternity, I left with no other choice other than using these gadgets or the machines and the technology. I stepped upwards towards radiology, where my best partner is nothing but the machines. I deal from the likes of digital x-rays to the most advanced machines like PET scans and the proton scanners. So that means, where am I standing? Is these machines are going to remove the human interference and the medical interference of the human being in the fraternity? No, it won't. No, it can't. It's not that it won't, it can't. Because all the algorithms at the end of the day, it's all been written by ourselves, human beings. So, ourselves and our human brains are irreplaceable. But in saying that, this AI, the latest term we are using in the recent, especially in the, I would say like the couple of years or maybe in the last 5 years, it's inevitable, it's unavoidable, I would say. Then I was just doing my own research to see when this real AI has started. And I was stunned because it was started in early 90s, even before that. But it has come into the practice only in the last few years, in a very intense way. So, I'm going to talk only about ourselves, not by the machines, not by the algorithms, not by the AI, but what these combined technologies and the AI kind of softwares are interfering our human body. Because the remarkable happenings, evolution, and this technology upgradation is astonishing without a doubt. But to me, what this technology is doing to us as human beings. So we are the most important commodity of this planet, right? We can live without a phone. We can live without any gadgets. We can live without a television. We can live without a car. We can live without a bike. We can live without traveling anywhere. But can you live without 2 kidneys? Can you live without a heart? Can you live without a lungs? No, you can't. So we ourselves are the most important species in this planet and even in the universe, number one. Number two, how these technologies are going to extend our lifespan, or in other words, heal if something happens to us, is very important question we need to ask ourselves. So I'm going to just briefly explain about what AI or what these kind of technologies, not only AI, there's a lot of technologies evolving in medicine too. And what it's going to do to us is what I'm trying to achieve here. Okay? For that, I need your complete participation, alright? And please cooperate. If I'm boring, please raise your hands. I'll stop there and I'll walk out. I have no problem. I will not take it in a bad way, okay? Remember, we were all sitting there at one point of our lifetime, and I know how boring it could be at times, alright? But just stay with us, okay? So, I would rather have a hand mic if you have one. Yeah. Apple Watch or any other wearable devices. It says very clearly, Listen, you have been sitting there for 40 minutes. You need to get up. You need to move. Hello? Yeah. So I am trying to move because my legs are frozen. So what I'm trying to say is, this technologies, all sort of technologies is really is remarkable. But as I said, I was against all these things because I thought at some point of time, these technologies is going to remove ourselves. That means I was thinking I might be jobless in future. But then I realized, no, we won't be jobless. Why we won't be jobless is, when you always keep enhancing your skill, who is going to replace you? Nobody. So what you need to take from this session is, it's not the knowledge you need to just take away. The knowledge you have to convert into your skill. Skill is important. Skill comes only out of your knowledge, but skill comes only by practice as well. So you keep just trying to do something which is useful to yourself, your career, from all these 2-day sessions, okay? Now, what AI does to the medicine fraternity? See, even using these are very nervous to me because I'm not used to all these gadgets. But that's the way you are. We have to adapt ourselves. And AI adapts itself so fast. Listen, I'm not going to bore you about what is radiology, because I know you guys know all these things. You guys are really smart. This generation kids, I really admire. But it's a custom that we need to introduce ourselves, right? Even though it is boring. Radiology is something like where it has become inevitable. I'll tell you one reason. In early 90s, okay, I'll shoot to Chamal. Our Indian system of medicine, right? You know what is Indian system of medicine? The alternative medicines. Can you name a couple of them? Brilliant. Siddha, Ayurveda, Unani. There's so many. Acupuncture is not ours, but we have embraced it. Those type of medicines in those days has got a greater potential to heal. But they don't have any tool to diagnose the ailment. Or நம்ம நிறைய தமிழ் சினிமா பார்ப்போம்ல பாப்போமா நான் பார்ப்பேன். So if you see those 80s 90s movie, in Tamil movies you see, if a person ஒரு பொண்ணு போய் வாந்தி எடுப்பா சினிமால, உடனே ஒரு பெரியவங்க போவாங்க, ஒரு பல்ஸ் பிடிச்சு பார்ப்பாங்க, and say, oh, she's pregnant. Correct? பார்த்துருக்கீங்களா அதை? Yes, it's a factual thing. That was the knowledge they had in those days. That the skill was passed down to the next generation, because a pregnant mother will have a double pulsation system which you need to feel. நீங்க ரொம்ப அதிகமா your arterial capillaries press பண்ணீங்கன்னா பல்ஸை ஃபீல் பண்ண முடியாது. நீங்க ரொம்ப மேலோட்டமா ஃபீல் பண்ணீங்கன்னா you feel பண்ண முடியாது. You have to give certain amount of pressure to feel the double pulsation. எனக்கு அந்த கிடையாதுங்க. ஏன்னா எனக்கு யாரும் சொல்லி தரல. But what has happened in the late 80s and the early 90s, this technology revolution started happening all across the globe, and we are no excuse to it, because we are the most important faculty in the whole world. So what happened was, WHO, or organization which you all know, World Health Organization, enna pannanga, if you want to do any treatment process, you have to go through a process nu soltan. Orthan kaila odachittu vandana, you should not put a plaster of Paris without doing any X-ray, and you need to document it. Abdin arambichadla irundhu till today, anything you want to do, you have to do and go through the diagnostic process. Proper machine kulla potu unmeile prachana iruka illaya therinjittu, then you have to do the treatment in oru SOP, standard operating procedure. They have introduced all across the globe, and we are practicing. For example, எவ்வளோ பேருக்கு இங்கே புத்தூர்னு ஒரு ஊர் இருக்குது தெரியுமா, நியர் திருப்பதி? Guys know? ரொம்ப ஃபேமஸ் ஃபார் வாட்? மாவு கட்டு. They never had. Now they are also using our machines. But before, I would say in 90s, if you go there to that place, I was there with my father once when I was a really little boy. My father fell from somewhere and he broke his, I think it was the elbow. So I just accompanying, I didn't do anything, I just accompanying. I was like 11 or 12 years old. And what happened was, this gentleman came. He was like not even wearing a top or a shirt. A dirty dhoti was wearing it. He came and he just made my dad to sit on a chair and he just felt his arm. I don't know what he felt, to be honest with me. Myself, I was just talking, what is he doing? And then he said, okay, fine. I think it was somebody else was accompanying us as one of the relatives or somebody. He asked them to just go and get something, like the bamboo sticks and the used dhotis they were using it. Used dhotis, not even fresh dhotis. And then he brought these things. They had their own concoction of the so-called herbal, as I said, concoction. ஒரு பச்சைல மருந்து அதை உள்ள வச்சு the bamboo sticks வச்சு they wrapped it. Unbelievably, he got healed in 4 weeks. That's a different story. But even if you go to the same place now, they will tell you, sir, please ஒரு x-ray எடுத்துட்டு வந்துருங்க. That's what as technology and machine learning, machines, now we talk about AI, has done to our fraternity. Mr. Shiva was talking about Steve Jobs. It was really interesting. I am a great fan of Steve Jobs and I hate him to the core. I have a love-hate relationship with him for different reasons. He was the most arrogant guy the whole country or the whole world has seen, but he was a genius. He was an absolute genius. But he died because of cancer, which comes to my area. He was diagnosed in the second stage. Second stage like cancer in that, it is absolutely curable. Today, if you have been diagnosed with second stage of cancer, it is curable. And luckily, he was found or diagnosed with pancreatic cancer in the second stage, and the oncologists and the surgeons were advising him to go for a surgery. It's called the Hebler procedure. Pancreasல இருக்கிற ஒரு பார்ட் எங்கேருந்து அந்த கேன்சர் டிஷ்யூ ஸ்டார்ட் ஆகுதோ அதை கட் பண்ணி போட்டுடலாம். நான் ரொம்ப லோக்கலாக பேசுகிறேன் because that then only it makes understandable. And what did this gentleman do? As him being a very arrogant fellow that is in his genes, he refused. He refused to go to the surgery. So what happened was, he was living with the cancer for total was 8 years. But the cancer he was diagnosed was after 3 years. But he refused to do the surgery for the first 2 years after he's been diagnosed. So first 5 years he was living with cancer. What happened? What could have happened? It has gone to the third stage. Then with the pain and the agony and the procedures and everything, your mental stress, your body stress, he has given up of his idea of not doing the surgery. He agreed to go for the surgery, where in which that stage the cancer has gone to the fourth stage. And after the surgery went actually successful, but he lived only for 2 years after that. And the deathbed, the statements and the phrases he wrote was absolutely remarkable even today in the industry of philanthropic industry, medical industry, and even in the corporate industry, has what he has felt about medicine, life, money, corporateship, everything is actually told. It's in YouTube, and I recommend everybody to go to it. Why I'm insisting the same point which Mr. Shiva was telling you is, picking the point is, if 8 years ago, if AI was there, but it was not that intense, it was not that clever, like what is happening right now. The AI could have detected the cancer in the first stage. Even he would have made a machine or whatever. He has got billions of money to even treat himself, right? But AI wasn't that evolved that time. To me, that's one among the reason. AI என்ன பண்ணும் மெடிசனில் அப்படின்னு சொன்னோன்னா, உங்களுக்கு புரியுற மாதிரி தான் சொல்ல போகிறேன். எங்கள் ப்ரொஃபஸர்ஸ்க்கு புரியுற மாதிரி பேசவே போகிறதில்ல, because I'm not here for them, I'm here for you guys. Have you seen the movie Iron Man? Have you seen the movie Iron Man? Have you seen the movie The Passenger? Yes or no? Iron Man, what has happened? The AI is Jervis, right? The AI is Jervis. Jervis கிட்ட தான் command கொடுப்பான். And the AI-ல இருக்கிற அந்த Jervis has evolved to what? படத்துக்கு Ultron மாறும். It evolves as Ultron, right? Correct? Have you seen the movie or not? Guys, it is not just a student's life is to only study. You can also study through various means and ways, okay? Have time, see good movies, okay? Where in which the AI evolves like that. It will become autonomous at given point of time. Of course, we still can have a control on it. In the movie Passenger, why I'm trying to say is, where you can see, and the person ஒருத்தன் இறந்துருவான். This happens in the space, and they take this body, the dying person, I wouldn't say he's dead. They took the body, and they have something called medboard. அப்படின்னு ஒன்று இருக்கும். பார்த்துருக்கீங்களா படத்தில்? Where you throw the body into the medboard, and the medboard will detect what are all the whole anomalies in your body from your top to bottom, and tell you what is exactly is going wrong. This organ is failing, that organ is failing, this has to be fixed, that has to be fixed. Or 4 scanner சொல்லிடும். That is not in practice right now. But trust me, I would say maybe before I die, I might see that coming. Not to the whole level of what it has been shown in the movie, but some part might come into practice. Or at least we can have a concept of it or a prototype of it. Because it evolves so fast. Okay. நான் ஒரு தொழில் ரகசியத்தை சொல்ல போகிறோம் உங்களுக்கு. It's a secret where how we make money. Okay. You go to, how many people have gone to do any type of scans? Or a CT scan, MRI scan, whatever the nonsense of the scan in the market. How many people have done it? Can you raise up your hands? Okay. So you did only half scan, right? No, yeah. The scanner, the technology. I'm a radiologist, I'm telling you the secret of what we do. The scanner itself is being preloaded with a lot of algorithmic data. A lot of command process is already been embedded in the system. Okay? It has been developed after doing a lot of data analysis. When we say data analysis, we are talking about millions and billions of data. With that, they will tell you exactly what is wrong. Okay? That was even designed before AI. So what happens now is, if you go to a scanner, okay? I'll put a picture and I'll explain to you, you understand better. These are all, honest சொல்லிட்டுமா, I did this PPT just to put a PPT for PPT's sake. So don't worry about all these things. What you need to take now, why AI is important is what the agenda now I'm trying to impress on you. Got it? Why AI? Why we need to update our knowledge to AI? Sir sonna madri Azure. What is that? Something called Python. See, I am not a techie guy. I told you. That's why I put the disclaimer. Okay? But this is inevitable, and you need to focus in one among this area to enhance your skills. Is what I'm trying to achieve. Okay? So, for example. Oops. Can you just see? That shows my technology knowledge. Can you just? So what I'm trying to say is, இப்போ ரொம்ப லோக்கலா பேசுவோம். I am developing a heart attack right now. Okay, right now. ஒரு சின்ன எனக்கு heart block இருக்கு, எனக்கு தெரியல. I'm heavy tea and carbohydrates food substance சாப்பிட்ற ஒருத்தன் collapse ஆகிற. Graciously, some of you are taking me to a hospital. They are giving a first aid, and they found that I am going through a heart block. எனக்கு இருக்கிற 5 coronary artery, there's one artery is been blocked. அப்படின்னு diagnose ஆகுது. And then the doctor will say, அந்த diagnose ஆகிறதுக்கு முன்னாடி என்ன நடக்கும்ன்றதை நான் சொல்ல வரேன். Oh, yeah. So, how do you point this out? Okay, and can you see the blue area there? These two are the lungs, okay? These two are the right and the left lobe of your lungs. And these are, yellow lobe over these called bronchioles. Guys, I know you have read all these things in your plus 2 and 11, so you cannot escape saying that I am an engineering student, I don't know all these things, because you know all these things. So your bronchioles, where it is an airway, you take your oxygen through that way and gives off your carbon dioxide and all. அதெல்லாம் உங்களுக்கு தெரிஞ்ச கதை. But what I am trying to say is, oh my good God, what is happening? No, and I'm sorry, pardon me. No, see, that's my knowledge. Can somebody do for me? So what I'm trying to say is, I am hospital with a cardiac problem, right? Correct? My heart vessel is blocked, which is been diagnosed by a scanner. But this was in late 90s and early 2000s I'm talking. So you go for one problem, that problem is being looked after, doing the bloods. We will do an angiogram, and if they found there is a block, they'll do angioplasty. Locally சொல்ல போனா உள்ள இருக்கிற block-ஐ எடுத்துருவாங்க. They might put a stunt, they might put a balloon angiogram. There are so many ways are there. So what happens is, this is how things were treated till early 2000s. Now what happens is, if a same person, if you're taking me to now to the advanced scanner, which is called the 128 Tesla CT machine, if you put me in that machine, this is how the image will come. Okay, what is the big difference now? You can also find the anomalies of the whole thorax, chest and thorax. You can see all the anomalies. Okay, anomaly therinja yavan kandupidipa, right? I am not the one. I am a radiologist. I am not doing the scanner. Some technologist is doing the scanner. Please understand, no radiologist put a person or a patient into the scanner, or a radiographer or a radio technologist who does the scanning part, taking the person, putting in the scan bed, sending and doing the procedures, and they are the one using the gadgets to even to scan. We call them as scouting. We call them as scouting. To see, you place your cursor in wherever the areas you want to get scanned. So what happens is, now the artificial intelligence embedded in the CT and the MRI will scan the whole chest. We are putting the person inside, right? Instead of scanning one particular area, the AI will scan the whole chest, will tell you about, hey, listen, look, it is not just your heart has got a problem, there is a problem in your lungs, there is a problem in a mediastinal cavity, there is a problem, there is a node appearing in your spleen. It will tell you everything. You understand what I'm saying? So, nobody is giving a command to the AI to tell what has been happening. The AI does by itself. That is the most important part of AI, particularly in radiology. I can talk about the various involvement of AI in all of the medicinal faculty as well. But what I do, I'm trying to say. So what happens is, life is being saved. Romba simple. Life is being saved. It might sound really a statement, but if it happens to our families, we'll know the importance of it. I really mean it. I've seen lately after COVID, how many people have suffered with COVID? Boys and girls. Guys, if you leave me, I'll finish in 10 minutes. If you don't cooperate, I'll just drag you to another 40 minutes. What do you want? 10 minutes. Right? Yeah, I know. So cooperate with me. How many people have suffered with COVID infection? Right? Right? Ninga COVID infection first what has happened? What has happened? How did they do it? How did they treat you? How did they diagnose you? First, they'll put a pulse oximeter in your finger, correct? To see what is the blood glucose level. The blood oxygen level. What is the blood oxygen level? It has to be 100%. Whereas in COVID cases, the oxidation saturation won't be there because your chest is compromised, right? Unga lungs la infection poido, airborne infection nalla. So your COVID infection has gone into your lungs, where it is trying to grow inside. It's called colonization. The colonization happens in your chest cavity. It blocks the airway, and the oxygen won't go inside to all the organs, wherein which you will face a multiple organ failure within a day if you don't treat yourself properly. So what we need to do is, first is finding your oxygen saturation, right? It is only a bioinformatic tool. That's a bioinformatics tool. And now, with after the usage of what has happened in the last 3 years. See, 3 yearsல நிறைய வேலையை வந்து AI எங்ககிட்ட இருந்து புடுங்கிடுச்சு. எங்களுக்கு தொழில் போயிடுச்சு. That's the honest fact. Because 3 years before, how many people have even heard about a thing called oximeter? Nobody. Unless you are a paramedical person or a medical person, you wouldn't know what is oximeter. Now, everybody knows what is oximeter is. So when there is a usage is growing, what happens is that these guys who are manufacturing is embedding this AI into this technology. So now what it does is not only just predicting your oxygen saturation, it also tells that your chamber is compromised. This you not see it in the small things which you're using, but the things which we use in the hospitals will tell that the blood flow of your inferior vena cava is compromised. Adu varaikum vandiruchu. So then you go to your person, you take the person with COVID positive. We know that the oxygen saturation is only 60%. You have left with no other choice other than putting the person with the ventilator. When you put a person with the ventilator, it's called the automated ventilator system, which means in olden days the ventilators we have to put the settings up. The airway pressure. Okay, thank you. The airway pressure நம்ம fix பண்ணும். Okay, there is a lot of things. I don't want to confuse with the terminologies. There is something called CPAP, continuous airway positive pressure. That means the pressure of the air has to be even controlled. For example, I'm a guy new to a gadget in ICU. நான் நேத்து தான் ஜாயின் பண்றேன் ஒரு ICUல. I am qualified, but I am not trained in that particular machine. The machine, for example, I am trained in GE machine vechingo. The machine where I worked was in GE, but the new hospital which I've joined is say maybe they might be having Siemens machine, where obviously it's like using an Apple phone and an Android phone, right? It will take a couple of days to get used to it. So there might be a possibility of doing some mistakes there, correct? Imagine if I do some, for example, if instead of putting a 99 degrees positive pressure, what happens if I put 110? The lungs will take more oxygen and it will cause more problems. That should not happening. As the same way, kammiya vechitalo, the person will go into a hypoxic level, which will elevate the condition and it will go into a comatose stage. So both is not advisable. So what we do is, I didn't do anything. What the machine does is now is called the AA integrated ventilators are there in the market now. So what you do is, time is essence here. A person cannot live without an oxygen for more than 3 minutes. It's not 30 minutes, it's 3 minutes. So time is essence. So what I need to do is, what the technology helps to us is, take the person or the patient, put them in the ventilator and put the automatic mode. Immediately it detects everything. What sort of oxygen need, saturation is needed there. What type of amount is needed, what quantity is needed, what saturation is needed, what pressure is needed. Everything is being done by the AI itself. So it reduces the work burden. More than the work burden, it reduces the error. In our faculty, there should not be any room for error. So this is the very important task and the role of AI in medicine. I'm only giving a tip of an iceberg example. I can give you 100 million examples. I can give you live scenarios which I handle myself. Okay, I'm not going to take much of time. I will give you 2-3 examples to see what is the importance of AI, okay? Right now there is a big celebrity in Tamil Nadu has passed away, right? Mr. Ilayaraja's daughter has passed away, right? She's passed away because of cancer. The problem is she was having an abdominal pain for quite some time. Don't know how long, maybe a year or 6 months or whatever. She is a bad eater. She thought herself that the abdominal pain is due to maybe an ulcer, or as like any other gynecological problem, she thought she might be having some uterine issue or whatever. She thought like it's an extended period of cramps she might be having, and she is entering into a menopausal phase. So mind was fixed with all these kind of areas. But she was developing pancreatic spleen cancer. And she was diagnosed. See, you know the money Mr. Ilayaraja would have made. He has thousands of crores of money. He had only one daughter. He could have taken the doctor to the Mayo Clinic in US. He could have taken the doctor to anywhere, or he he can build a hospital. Money doesn't help them. But early detection of any ailment is absolutely possible with AI. It is no doubt, I'm telling you, it is really is dangerous in human interference, but it will happen. It will happen. It is already happening. There is a proton scanner right now. It has been implanted in Chennai. The cost of the scanner is 16.5 crore. Okay? It is an unimaginable money for treatment, but I'll tell you what, it will save millions of lives. It will save millions of lives. Why the scanner is expensive, why the scanner does all this thing is because it is embedded with the AI. You don't need an oncologist. You need an oncologist only to read the conclusion of the imaging. கடைசியா இருக்கிற 4 வார்த்தை இருக்கு பாருங்க, conclusion பார்த்திருப்பீங்க imagingல. That is all you need to know how to read. You need to have the knowledge of understanding whether the scanner doing the right job or not. The scanner does everything. The same way, we ourselves are entering into a genomics project where the genomics என்னன்றது கொஞ்சம் complicated. I don't want to dwell into it. Same example நான் எடுத்துக்கிறேன் cancer ஏன் பேசுறோம்னா cancer is genetic. AI is also it's something like genetic man-made thing. It evolves, genes evolves, cancer evolves, AI evolves. அப்படி போயிட்டு இருக்கு. So I'm taking the same example of a cancer. Say for example, I'm developing a type of cancer, say prostate cancer vechingo. This cancer is been diagnosed by taking a small tissue sample called biopsy. கேள்விப்பட்டிருக்கீங்களா? Biopsy specimen கேள்விப்பட்டிருக்கீங்களா? So this biopsy specimen will be converted into your bioinformatics data. Okay? There is a machine called Lumina, which is actually in California. It is done and it is still there in California. This machine converts your biological tissue into a binary code, binary data, 0 and 1 மாத்தி கொடுத்துரும். ஏன்டா இந்த வேலை செய்றேன்னு கேட்கலாம்ல. What stupid ஆ நீ இங்கேருந்து ஒரு டிஷ்யூ எடுத்து அமெரிக்கா அனுப்பிச்சு ப்ராசஸ் பண்ணி stupid ஆ நீ கேன்சர் தெரிஞ்சு போயிட்டு why don't you give a drug, man? There is 100,000 drugs in the market. Trial and error ஒரு 3-4 drug கொடுத்து விடலாம்னா that is how the treatment was happening so far in the world. But that is all getting stopped out. Reason being is precision medicine is coming into a play. Precision medicine அப்படினாலே it's like precise treatment ன்னு அர்த்தம். You are giving a precision treatment. There should not be any room for error. ஏன் room for error சொல்றோம்னா 3 மாசத்துல கேன்சர் ட்ரீட் பண்ண முடியலனா வேற ஸ்டேஜுக்கு போய்டுமா? வேற ஸ்டேஜுக்கு போய்ட்டா பேஷண்ட் இறந்து போய்டுவானா? ஸோ நான் ட்ரையல் அண்ட் எரர் பண்ணுறேன். 3 drugs I am giving it to myself for my prostate cancer. Say, assuming I have a cousin or a nephew or the same blood group or some of my families who I think might be genetically related, develops the same kind of cancer and the oncologist giving a same drug to him and I think, okay, my nephew and cousin has been treated. அவனுக்கு work out ஆயிடுச்சு. That anti-cancerous agents or the drugs is been successful to that person. நான் போய் என்னோட oncologist கிட்ட if I ask him to just prescribe the same drug, he might prescribe, but it doesn't mean it will work on me because cancer is genetic. It is like your fingerprint. Everybody's genes and the genomes are unique and non-identical. In other words, if that's the case, non-identical genomeல அவருக்கு இருக்கிற கேன்சரும் எனக்கும் சேமா ஒர்க் ஆகாது. So what we do is this AI comes into the play in converting this biological data into a binary data, bioinformatics data through a synthesizer. Okay? என்ன பண்ணும் அது? Okay, நீங்க biological data you are converted into a bioinformatics data. What you are going to do is there are 126,000 drugs for cancer in the world. What AI does is, what we are trying to do is AI is going to cross match that particular genome with the available drug to say, hey, listen man, hey Bhumi, for you this drug won't work, only that drug will work. So it will give you a precise diagnosis and the treatment modality. It's called the theranostics. It will give you a theranostic approach of picking the right drug. Even if it takes 2 days time to find the right drug, that is okay rather than just waiting for 3 months or 6 months, right? We are getting saved. The lives are getting saved by this modality. So like this, precision medicine is happening everywhere. We used to have, like girls, you might know, boys also will know, when a mother or a sister or your niece or whatever gets pregnant, they go to a radiologist, gynecologist, first trimester, second trimester, third trimester, they'll go for an ultrasound scan, right? To see the baby's movement, correct? Why do you need to see a baby movement? 50 years ago, who was seeing the baby's movement? Nobody. Now what happened to you guys? Why you want to see a baby's movement? I'll tell you why. There is two reasons to it. One, it's a psychological satisfaction to see a baby moving inside the mother's womb, right? I have two daughters. I know the feeling of the first time I was seeing my daughter just floating in my wife's womb, and I was in tears. That is one reason. But the important reason is not that. The important reason is we want to see whether the child, the fetus is happy, normal, and without any genetic deformities. Cleft lip kellipatirukingla? You know the cleft lip conditions? Cleft palate, cleft lip, where the lips were twisted. These are genetic conditions. When we know this baby is going to have these things, when we know that this baby is going to birth with, say, there is something called dextrocardiac, the heart frontal irukadu, pinadi irukum. This is called dextrocardiac. These are all genetic anomalies. I can go on telling about a lot of conditions, okay? I don't want to bore you. You are hungry, I am hungry, I am thirsty too. What I am saying is, now we have a 5D scanner. Initial days la neenga paatha scanner is all black and white, right? Cinema la paathirpingala or sheet irukum. Vala or sheet irukum. The doctor will put it in a light and see, all right, this fellow has got this. You have a baby boy, you have a baby girl. Now those days are gone. Now we have a 5D scanner where you can, when we do the ultrasound probing, you can see the baby's picture as clear as a picture taken from an iPhone. As clear as a video taken from an iPhone. So what is it important? Say for example, those days, your lecturers and the senior people, thank you so much, thank you. The senior people will know about these kind of things. Stillbirth in solvo. In other words, Kurandai, Karuvil Irandu Pirandrum. That's called stillbirth. Okay? How it happens, most of the times, tangling of the cords in Zulwanga. It's called the tangling of cord or cord tangling, meaning cord, which connects the mother and the fetus. That umbilical cord, we call it as the umbilical cord, placenta. The placenta is nothing but a tube, fine tube, right? What happens is get tangled in your neck. Koranda is going to float in the womb of the mother. When you're floating around, it's like swimming in a pool, you might just twist and turn, do all stunts inside, right? There might be a chance that the baby or the fetus neck can get tangled with the umbilical cord. What happens? It's like strangling yourself. What happens? Your hyoid bone will get cracked and it will cut off your oxygen supply and the person will die immediately, right? Outside. Whereas inside, the baby dies gradually. If the cord gets tangled in the neck of a baby, the baby dies within 6 hours. Which mother wouldn't even know. Mother thinks the baby is sleeping inside, but the baby could be dead. But with the 5D technology, what happens is, you know exactly what position the baby is. Now the 5D technology is being evolved in such a way that you can make that ultrasound scanner into this small machine. It's like your oximeter. Now almost everybody have an oximeter in home, right? I would say in 5 years time, this kind of machines comes, and when you're pregnant, you can give to your wife and then they can have it. All they need is a phone, which we all have, a smartphone. You put the probe into your belly and you can see the movement in your phone. That is going to happen. Trust me, that will happen. How this is all is possible is just because of AI and technology. I can keep on going on and on and on for another 3 years, 5 hours, 5 days I can do this. I can give live examples, but I know it's the awkward time and I am always cursed to get the timing in the middle like this or after post-lunch so people will fall into sleep. It's okay. But what I'm trying to say is, being engineers, listen guys, I'm finishing in 2 minutes. Please pay attention. This is the important part. Why you need to know what a truck company is doing in America? Why you need to know what a stupid doctor is doing in radiology with all this AI? Why you need to know the other company is doing the defragmenting of the chip and making it into chiplets. Why you need to know? First and the first more question is why you are here? Why you are here? What? அப்பா அமிச்சிட்டானுங்க நான் ஏதோ ஒரு ஆர்ட்ஸ் அண்ட் சயின்ஸ் படிக்க போக வேண்டியதான் எங்கள் அப்பாவோட ஆசையை நிறைவேற்றதுக்காக எங்கள் அமிச்சிட்டான். கரெக்ட்? கரெக்ட்? Yes or no, man? Yes, sir. So for some people it could be yes. But what I'm trying to say is, தெரிஞ்சோ தெரியாமலோ, you have come here. Correct? Boys, the last row benches, can you just listen? With your knowledge or without your knowledge, without your concern or with your concern, with your wish or without your wish, you are here. Correct? You are in the college. Arrear, without arrear, you are going to finish your graduation. Correct? Correct? No problem. என்ன எக்ஸ்ட்ரா நான் இன்னும் நாலேஜ் அதிகமாக வளர்த்து வெளியே போகிறேன். வித்தவுட் arrears இன்னும் குறுகிய நாலேஜில் போகிறேன். ஸோ இட் doesn't make any difference. Doesn't make any difference, to be honest. What knowledge and skill you are taking home is all is important after your college days. Nobody will be there when you go to employment will teach you what is what. They will always criticize you. Hey, என்னடா படிச்சுட்டு வந்தேன்னு கேட்பான். எந்த காலேஜ்லேருந்து வந்த, எந்த அறிவில் வந்தேன்னு கேட்பான். You don't want that, right? You will be embarrassed in front of your fellow colleagues. That is very important. More than that, it is a very competitive industry right now. If you want to hail in a competitive industry, you need to have an extraordinary skill in whatever you do. Whatever you do, your skill has to be on the top-notch level. If not, you will not excel in your faculty. For that, you need to understand which one to take. இப்ப என்ன நடக்கிறது? What is going to happen in the next 5 years? Where the technology is going to evolve in the next 10 years? This is all is important. That's why we are trying to prompt you and to actually enlighten and uplift your knowledge a wee bit to say this area is evolving. So focus in this area. That's where our சொன்ன வார்த்தை நீங்க கேட்கணும். See, there is a job opportunity ன்னு சொல்லிட்டே இருந்தார் அவர். Mr. Shivakumar was insisting, it's big data பாருங்க. Big data is happening. Data analysis is a job where you need to get trained on. AI, Azure, Python. He's telling all these words, right? These are all cues to pick and choose which role, which course you have to take. அது உங்களுக்கு இன்ட்ரெஸ்ட் இல்லைன்னா you can take a different course. But again, to take a different course, you need to know what is the future of that particular course or the certification or the skill is. Correct? That is what these workshops are all about. You can take it or leave it. But if you want to hail in this fraternity, pay attention. These people who are sitting here are not just here to do in a workshop and walk away. They are doing projects. In other words, if we find that there is one girl or one boy has got the potential and got the skill from this college, there is a fair chance that they could be hired to US. There is a fair chance that I could even take them to Ireland. I have a company established in US too. We are getting into genomics research. I know your bioinformatics department people personally. I might recruit 4 people from bioinformatics because I need them. But if I don't see any potential knowledge or skill from this group, why should I take them? So your role is to understand all these things. Try to pay some attention. Your college timing is between 9 to only 5. Study only in this time. You don't have to study. I don't believe in studying home and all. I personally don't. If you are unable to pay focus and study and gain knowledge between 9 to 5, you cannot gain knowledge even if it's 24 hours. Correct? So in your college hours, make the best use of it. It's a beautiful time of your life. You can go and torture your professors, lecturers, deans. You have an amazing faculty. Okay? Torture them. Just enhance your knowledge, enhance your skill, and hail as a beautiful butterfly from a cocoon is what is my wishes. So I am just trying to conclude with this because half the guys are there just nodding their head. So I understand. And thank you so much. I would like at least half of you people to just get out from this country, learn more knowledge, make extraordinary money, make name and fame, come back to India. Okay? And again share the knowledge. Invest your money back in your own country and flourish from there. Make your parents and your homeland proud. Got it? Thank you so much. Thank you.
Brahma, Guru Vishnu, Guru Devo Maheshwaraha, Guru Sakshat Parabrahma, Tasmai Shri Gurave Namaha. Respected teachers, respected principal of this college, distinguished speakers, and my dear students, Today, we are going to discuss about such a research work that has become one of the most hottest trend in the AI ML domain. We are going to talk about such a work that has posed the challenges for which the entire research community across the world is working relentlessly to find a solution for it. Today, we are going to discuss about such a work for which the big corporate houses have spent millions of dollars money engaging their research community to find out a solution with both hardware and the software for such a challenge that has been dominating in the industry. And that work is related to how can we actually address the challenges, the problems, the limitations that exist when we try to deploy a pre-trained AI model onto an edge IoT device. So this is what this work is all about. Okay. It means what it does is that it takes a pre-trained model that is trained by someone once we don't know, that we need to actually put it on some other hardware. Okay. So in the coming slides, we are going to discuss about all these points, the introduction, wherein we give a background about this work, what work is this work is all about, and the challenges that this work is going to address, and what are the solutions so far found by the research community in the past, and even after that, what are the limitations, what are the problems, what are the research gaps still exist so that now we are going to solve it, and what is the proposed solution in the present work, and what are the results of the experimentation we have conducted, and then finally we are going to conclude this, comparing that with the earlier works. We have the AI technology, as some of the distinguished speakers have actually spoken earlier also, it is gaining such a wider popularity that it has started to penetrate into every field of our human society, right from the simple prediction and analytics to the complex work of image processing, and even to the time critical applications like industrial robotics and self-driving autonomous vehicles, the mission critical applications like the avionics and the defense sector. So these are all the areas that it has gained its popularity and already started penetrating it. A large scale of AI deployment has been happening across the globe, but at the same time, there are so many challenges also it is actually posing towards the research community. It is not that simple. It is not that simple to deploy a pre-trained model as like, building some hello world executable and then running it on the CPU. There are many challenges, and that we are going to actually find it now and address them. Okay. So what are those challenges? Okay. As I told you just before, that this work is all about, we are taking a pre-trained AI model. You take any AI model, right? We have done some, house price prediction algorithm, some machine learning algorithm, some classification algorithm, some CNN model for image recognition, right? These models you have learned, right? Yes. Who are all learned the AI? Can you just raise your hands? Yes. You have learned something about supervised learning, unsupervised learning, classification, CNN, DNN, right? So these are all the models, okay? These pre-trained models are trained using these algorithms. That is actually developed by someone else. We are not developed it, okay? Maybe some big research institutes, they have developed it. And we need to take that and port it onto another hardware, okay? That is where the first challenge comes. Because there are hardware architectural differences between the processor on which these pre-trained AI models are trained and the processor on which we are going to deploy it. One simple example I will give you. Let us say now you have developed your AI model, right? That is on your Intel PC, right? Likewise, these models are also, trained on, assume that on x86 architecture. Now I want to take it and deploy on it the ARM architecture. Okay. Will it run? No, right? Yes, we need to make it run. But we need to make it run in such a scenario wherein we don't have the source code. The pre-trained model, right, it is like an executable. It is one A dot out of your Hello World program you write. We don't have the source code to modify that. You should actually work on another, the hardware platform. We don't have that luxury. Even in that difficult situation, we have to actually make it the architectural compatible with another hardware and make it run, okay. This is what is the first challenge. The second challenge is these pre-trained AI models, right, they are trained on big servers, okay. Big cloud servers. In big research laboratories, they will train with, having high computational capacity computers. Because of the reasons that these models are very large in nature and it needs very skilled manpower and also high-end processors to actually train them. Okay. But the edge device that we are going to deploy them doesn't have that, that type of computational capacity. It comes with very low computational capacity, like Raspberry Pis, your Atmel microcontroller, your MCUs, right? So those are the devices that are made use in the edge IoT devices. You just imagine the computing capacity of these edge IoT devices. Their, operating frequency could be a few hundred megahertz, okay? And also, you can actually, I think you might have actually programmed using the microcontrollers. So how much memory size you will get at the max? Anyone? Few hundred kilobytes, right? Maybe 200 kilobytes, 300 kilobytes. But these models are large in size that they actually go up to from hundreds of megabytes to gigabytes of size. And that we need to compress. And make it actually fit into the few hundred kilobytes or few megabytes of memory available on the edge IoT devices. So this is another challenge. The third challenge is that because if you can compare the processing capacity of the high-end servers on which the model is trained and the computing capacity of the edge IoT device, they cannot match each other. If the clock frequency of the high-end server is around 2 gigahertz and 3 gigahertz, and here the operating frequency is around few megahertz, or at the max 1 megahertz, how you can actually improve its inference speed? Inference speed is something in which you feed the input, it processes and actually predicts the output. This is called the inference, okay? And the time it takes to do so is called the inference speed. Now, because the pre-trained model has got, the hardware architecture on which the pre-trained model was actually running, that has got higher clock frequency, but the edge IoT device on which actually you are going to deploy it has got the lower clock frequency. Do you think that logically, will the inference speed improve? No, right? But still we need to make it improve its inference speed on the edge IoT devices. So this is what the challenges that the research community has got across the world, and lot of research is going in this field. How we can actually take such bigger, larger models and deploy onto the the smallest edge IoT devices. So these are all the challenges that we are going to address today. And at the same time, one more criteria is that the accuracy should be maintained. Because I think the people who have trained the AI models might be knowing that you might have actually struggled a lot to actually bring up its accuracy, right? You tried, few hyperparameters. You started with the base model. It gave around 60 to 70% of accuracy. Then you did the hyperparameter tuning, and then it actually improved. And then again you tried some other, permutations and combinations of it, right? This is how you did. But here that luxury we don't have. because the model is already pre-trained. I don't have the source code. I cannot go and actually modify the code there. That luxury I don't have. But still I need to actually do this, okay? So these are all the challenges that are posed towards the research community, and let us see what the research community has done across the globe to find solutions for it. Okay, in one of the research work, what the research community has done is that they have come up with new software algorithm to reduce the size of the pre-trained model itself so that it is able to fit into the available memory capacity of the edge IoT device. One approach they took. And I will tell you actually what they did. They came up with many various algorithms to reduce its precision size of the weights and the bias, the layer fusioning, weight pruning, all those techniques they adopted, and finally they made it to somehow, they made it to fit into the limited memory of the edge IoT device. Though one problem is solved, but it has posed another problem that though they were able to actually fit into the edge IoT device, they could not actually increase its inference speed because, as I already told you, right, it has got the lesser clock frequency, less computational capacity. For that, what the research community did is they actually came up with this approach, okay? They made a topology of, instead of one edge device, they took multiple edge devices, made a topology of it like this, okay? And they choose the heterogeneous devices. It means not all the devices, edge devices made use in this topology are same. In one device was the microcontroller, the second one was the MCU, the third one was the Raspberry Pi. Like this, different devices they took and they made the topology of it. After that, what they did is, they actually, the input test data that we call it as an AI workload. It is like the image you are feeding, for it to recognize whether it's a dog or a cat, right? So that is called the AI workload. So what they did is, the entire workload, they partitioned it. Multiple independent doable tasks like that, they have actually partitioned it, and then they offloaded, they loaded the partial AI workloads onto different heterogeneous devices. So what they now, after that, these heterogeneous devices used to compute whatever their part they used to compute, and then the partial output was combined at the final node, and the result was displayed, okay? With this approach, they were able to succeed to some extent improving its inference speed, but they could not actually overcome the speed of the pre-trained model on the processor on which actually it was trained, okay? They improved a little bit, but they could not actually go beyond the speed of the pre-trained model. So for that, what they did is, they actually came up with another approach. Okay, and here, even it has got the few disadvantages. You can see that there is always a fixed time that is taken to actually offload the data, to load the data on all the edge devices, and the time it takes for data exchange between the multiple nodes, there is always a fixed delay. And also, if one of the devices actually fails, right, then the whole system collapses. That is what its disadvantage, this approach. So for that, what the people did is, the research community came up with another approach. This time what they did is, they took the edge device, they also actually kept the high-end server, processing servers in the cloud. So what this edge device is to do is that, it used to actually collect the input and then send it to the remote cloud for computation over the public network. Because the cloud has got high computational capacity, it used to compute this input data and then send back the result to the edge IoT device for displaying the final result, okay? Yes, because of the high computational capacity of the cloud, they were able to process it faster, but this method has also got few disadvantages. Can you tell about, can you tell me what drawbacks this method has got? Anyone with a general approach? Though it might be wrong, I don't mind. Because the data is going on the public network. The input data, test data is going on the public network. Public network is subjected to different traffic conditions. What if the public network, IP network is congested due to heavy traffic? Then what happens? It will delay, right, the data exchange. This will delay the inference speed, right? And also, when the data goes over the public network, we cannot guarantee that. Someone can steal it, steal the data. Data security is a very important because it is a public data. It is very important data that we are actually exchanging. So this method has got this drawback. First, let us actually understand the problems. What are the challenges are there? First, let us first try to understand. Only then we are able to actually provide the actual solution to it, right? And also, if the link goes down, then the system collapses. This is what is the drawback of that. So in order to overcome this drawback, the research community came up with another approach, okay? And let me show you what is that approach. They actually designed a special hardware using FPGA that was very specific to the type of the pre-trained AI model that we want to deploy. This time they came up because they don't wanted to send it to the remote cloud or public network because of those disadvantages. They came up with this approach wherein they designed a new hardware itself using FPGA that is specific to the pre-trained AI model. So with this, they were able to improve the inference speed as well as they were able to fit into the available memory size of the hardware. It worked fine. It worked fine. But even this method has also got one disadvantage that, as I was told a minute ago, that the FPGA hardware was designed specific to the pre-trained AI model. It was specifically designed for one particular AI model. Suppose if you want to deploy another AI model, you cannot, because the hardware is designed for that particular AI model. Right. So this is what the disadvantage it has got, and we need to address this challenge also. Shortly we will see how you can do that. Okay. So in order to overcome this problem, the research community came up with another approach. Okay. So what they did is, this time, okay, oh, this I think it has not displayed, okay. So the other approach they took was, instead of FPGA, they made use of GPU, graphic processing unit, wherein it has got hundreds of cores. Compared to your laptop, which you are using now for your study, it has got only fewer cores, right? 5 core, 10 cores, okay. But this GPU has got hundreds of cores in it. Hundreds, 200, 300, 400, 500, thousands, depending on the need of the task. Separate hardwares are available, and it has got hundreds of GPUs on it. So instead of using the GPU, they tried actually deploying this pre-trained AI model on the GPU, and this time they succeeded. This time they succeeded compared to the FPGA in such a way that they were able to load every type of pre-trained AI model on the edge IoT device, because it is not specific to any AI model, right? The FPGA was designed to a specific AI model, but this is not like that. You can deploy any AI model on this, okay? But even this has also got one disadvantage, that though it has got hundreds of cores compared to the CPU, but what is the guarantee that the pre-trained AI model, when got deployed onto it, is executed making use of all the available cores in it? Is it guaranteed? Assume that there are 200 cores. You need to tell me yes or no. Like you write one program, hello world program. What is the guarantee that it is actually making use of executing on all the available 6 or 10 cores? Can you guarantee that? Do you have that? Do you build that intelligence or information in the program which you wrote? No, right? It executes sequentially. Now, in this case also, there is no guarantee that it has actually executed on the GPU, making use of all the available cores on it. So then, other cores got unutilized, right? They have gone unutilized. Do you feel that it is an efficient way of doing it? Right? Because you have actually, the cores were actually unutilized. They are going waste for you, on which you would have done some other task. And also, going back to this approach, okay, this approach has got another challenge that because these devices are very, slow, they take larger time to perform any task, to execute. It means they also consume higher energy. They consume lot of energy, lot of electricity they consume. So due to this reason, these are not energy efficient solution, okay. Whatever these approaches we have seen, right, these are all not energy efficient solution. We need to, when I design a solution, we should actually take care of all these aspects into consideration that nowadays there is a lot of talk, lot of discussion, lot of importance is given towards the carbon emission, preserving our environment, making this, environment a cleaner, a greener one. Suppose, what happens if it draws more electricity? Generation of the electricity has become very costly nowadays because of the insufficient rains. We are still dependent on the coal-based electricity generation, diesel-based electricity generation. That is a loss to any nation. Suppose if you deploy this kind of, the topologies. So now, having been actually posed with these many challenges, we as an engineer have to come up with approaches to solve all these types of problems, okay. Though these problems are solved, I'm not denying that the problems are not solved at all. But they are not solved entirely all the problems in one particular research work. Some people actually reduced the size, but the speed was lagging. Some people actually increased the speed, but it has got other disadvantages. Some people actually made it to actually work, but on which actually we could not apply the other AI models. Only specific AI models we are supposed to deploy. So different research works have addressed these problems individually, but not collectively in one the research work. So that is the reason this work is going to address all these problems in one single work. Okay, so what is the proposed solution? Proposed solution is to reduce the size of the pre-trained AI model and then deploy it on the GPU with hundreds of cores, and this time ensure that they are executed parallelly on all the available cores without wasting any one of them. And then this kind of problem, the approach taken is that the hardware selected is from the NVIDIA GPU that has got 384 CUDA cores, that has got 40 tensor cores, and that has got one deep learning accelerator. So with these, all those challenges which we talked about are solved in one single work. Using the CUDA computing, it was made sure that the program actually, the model runs on all the available cores without wasting not even a single core. And by making use of the DLA core, it is called the deep learning accelerator. It is a special hardware designed that actually executes the entire layers of the CNN on it very fast. Because of that reason, the amount of power consumed per execution of per instruction is very less. Because of that reason, it consumes very lesser power, and due to this reason, it achieves the energy efficiency. In order to solve this problem, along with the NVIDIA GPU, which has got a powerful processor, along with that, the NVIDIA GPU also comes up with a software called the TensorRT SDK. So what this model TensorRT SDK will do is that it will actually read the pre-trained model, because we don't have the source code, right? I told if you have a source code, then we can actually customize it. But we are in such a situation, we don't have even the source code. We have got just the binary That is called the pre-trained model. And what this TensorRT SDK will do is that it will actually parse the weights and the biases that are present in any model. Suppose if someone who has actually trained the CNN and DNN model, they would have come to know that we can actually get the model information by displaying its summary. So what this TensorRT SDK will do is that it will actually take the pre-trained model here and then it will feed to a parser. Parser, what it will do is that it will actually analyze the various layers present in the convolutional neural network as well as the deep neural network, whatever it could be, it will analyze the layers present in it, and after that, what it does is that it actually applies the model optimization configuration parameters. As I told you, right, one of the first challenge is to actually reduce the model size. How I can actually reduce it? Suppose if you can look at it closely, observe the students who have here actually trained the model, they will come to know that the model size actually depends on the number of parameters present in it and the size of the parameter, each parameter. The default size that is used for the weight and the biases is FP32, right? FP32 is the floating point 32 is the default size used for each parameter in the pre-trained model. Any model we want to train, so this is the default size we use. So what happens is that the pre-trained model comes with FP32 floating point size. This SDK has got one of the configuration option called the FP16 and the int16. It means the weight and the biases will be reduced from 32 bits to 16 bits and 8 bits. Okay, so this is the configuration we are actually applying while during the conversion of the model. These two. Suppose assume that the pre-trained model has got the size of 50 MB. When I apply this configuration FP16, the model size will reduce to half. It will become 25 MB. Suppose if I apply the configuration int8, so then what happens is the model size becomes 1/4 of the original size. Suppose if it has got 50 MB, then it becomes 12.5 MB like this. Okay, so one problem is solved now. We have actually made it to reduce to fit into the lesser memory of the GPU. The next one is how I can actually improve the inference speed. That is what the next challenge is that. For that, the NVIDIA GPU comes up with certain features called CUDA graph, CUDA computing, and the DLA core. So what it does is, let us see in the coming slides. After that, once we apply all these the parameters, optimization parameters, it will generate a TensorRT engine. This is nothing but as good as the pre-trained model itself. In the pre-trained model which you call in the NVIDIA GPU, it is called as the TensorRT engine. So once you apply all these parameters, all this the model optimization configuration parameters, the engine will be generated, the model will be generated, which is reduced in size, in which the intelligence is built in such a way that its inference will be increased when it is executed on the GPU, and also because the DLA core configuration option is tuned there, so all the layers of the CNN or the DNN, whatever to whichever the category the pre-trained AI models belongs, all the layers will be directly executed on the DLA core. Because of that reason, it takes very less time and hence consumes lesser power, and because of this reason, it achieves the energy efficiency. Okay, so now I am going to actually present you the results which I obtained when we did this. Okay, the pre-trained model size was 55,831 kilobytes. Okay. After doing this work, the size got reduced to just 487 kilobytes. These are all the actual practical results of the research work we conducted. And after doing all this work, the output which we got was this one. Okay. From 55,831 kilobytes, which was the original size, that got reduced to 487 kilobytes. You can see that it is a reduction of more than 90% of the original size, right? So this much reduction in the size we got. We got the size reduced. The other optimization we did was related to the increase in the inference speed. I remember that when this model was subjected for testing, we actually fed 10,240 images, which the pre-trained model running on the CPU took around 987 seconds to finish it. The pre-trained model that was running on the CPU, it took 987 seconds to perform inferencing of 10,240 images. But with the TensorRT engine, when the optimization was, when we built this model with int 8 configuration, it just took 2.4 seconds. It just took 2.4 seconds, that's it. The original speed was, the original time took was 987 seconds or something, but it got reduced to just 2.4 seconds. And also, because we made use of the DLA core, because it took just 2.4 seconds compared to the 987 seconds of the pre-trained model running on the CPU, I can say that it has consumed very lesser power, and because of that reason, this solution has also got the energy efficiency. And the fourth challenge was to maintain the accuracy as close as possible to the pre-trained model. But in our case, whether you believe it or not, the pre-trained model has got the accuracy of 97.41%, but our TensorRT engine got an accuracy of 98.41%. I can actually show you, if someone, after, when you connect me after, I can actually show you practically also. And because of the time restriction and the other, the speakers also need to speak, I want to just end my session now. Thank you for the time being given for me, and thank you to the IBM and the Ganesan who actually gave me an opportunity to present one of the work which I did towards deployment of the pre-trained AI model onto the Edge IoT device. And I thank all of you for your time here. Thank you.
Thank you, sir, for your valuable insights on the latest trend of generation AI and deep learning. Your expertise has provided us with a deep understanding of this cutting-edge technology. Ms. Anita, ma'am, our esteemed guest for this workshop. Ms. Anita, ma'am, is working as an Azure AI specialist. We are honored to have you, ma'am, to contribute your wealth of knowledge to this workshop. Welcome you, ma'am. The forum is yours.
Good afternoon. Are you all hungry? You had good food? Yeah. Okay, I'm not going to take much of your time. Let's talk about face recognition. So can you tell me where you use face recognition? In your phones, in your mobile phones, just to unlock it? Yeah. So I'm going to talk about how do you use generative AI to perform, to build an application of face recognition. Okay? And we're using Azure in this. What is Microsoft Azure? Does anyone know? Yes, you'll be knowing. You're all IT students. Yes, Microsoft Azure is a cloud-based computing platform, okay, which is used for storage and deploying major applications and manage applications. Talk about harnessing the power of AI using Microsoft Azure. So Azure, Google Cloud, things about cloud-based networks. How is data stored in a cloud? You have a lot of, you have Microsoft Azure, you have Google Cloud, you have AWS. So using all this, how does data stored in the cloud is like in data marts, You have any idea? In separate data marts, you store the data on the cloud. So for facial recognition, this is used in various fields like security, marketing, and healthcare. And we'll talk about potential applications also. do we do this? Now, what is generative AI? So, we talked about AI, right? AI has been there for decades. So, AI is just artificial intelligence. But now, what is the difference between a human being and a computer? We have a brain and we can think, right? Initially, computers cannot think. But now, what are we doing? With Gen AI, we are training the computer to think, to reason, to do logical reasoning, to perform decisions, to help us decide. So isn't that a big advancement? So this is what is revolutionizing various industries, and as all the speakers said, it's there in every industry now, AI. It's going to help you decide using, using this, it's going to surpass human beings' intelligence. Can you tell me if, our intelligence is going on increasing? No, right? Right from the time, human intelligence is just increasing at a linear rate. It is just the same. But what are we doing for computers? We are actually training it to perform tasks which not only we perform, but more than us. So more than us. So its intelligence is increasing at an exponential rate. So it will surpass human beings one day. 10 AI work. Okay? How do you incorporate this? And very, very simple terms, I'm going to explain it to you. Initially, it finds out patterns in a data set. You give an input data set. So example, your chat GPT, right? How does chat GPT work? You're giving an input, and it's going to identify a pattern in that data set, and it's going to give you output based on the input pattern you give it. So that's how you give, and supposing like you're asking it a question, it gives you paragraphs of answers, right? So that's how it works. So you just give a prompt. According to the human prompt, it works. And how does this happen? How does GPT know that it has to give you such amounts of information? By training. We train it, right? There are different types of training, like deep learning, adversarial learning. Adversarial learning uses GAN, and reinforcement training. Now, deep learning is a subfield of machine learning involving training and usage of AI neural networks to perform tasks. And adversarial learning is GAN, and reinforcement learning, wherein an environment is there and an agent is there. And the way they interact and create feedback gives rise to reinforcement learning. And these are the different models which you can use to build such applications. One is the generative model. Generative model basically tries to understand the structure of the data and generates new data based on the existing information. Discriminative model focuses on the differences between the data. Supposing like we have animals. So animals like cats, dogs, etc. So the generative model will just look at it as animals. But the discriminative model will give you the difference between. It will draw a boundary, say cats and dogs. That's what, just a boundary. Now what is a GAN? A generative adversarial network. It's a deep learning architecture which has two neural networks, like a generator and a discriminator. Generator, on prompting, it gives a lot of data, and the discriminator finds out the authenticity of the generated data by the generator. The next model is transformer model, and this processes the input sequence with help of an encoder, and you have a decoder which generates the output sequence. Now, depending upon what application you want, you can use the different models. These are some of the use cases of generative models. You can do text generation like ChatGPT. And ChatGPT can also do a lot of complex calculations like, finding out the ROI, etc. for business insights. Sentiment analysis is used in marketing for basically, to find out the consumer preferences, how the customer reacts to a particular product, and what kind of products do they want. Image generation and enhancement. Like supposing you want really good images, you can just type, just draw a monkey sitting on a wall or something like that. And then, it generates beautiful images of that. And you can also enhance it, like how you do it in your phone, right? You can just crop it, you can change the lighting and a lot of things. Code generation, it does give you a lot of code. You don't need to sit and write all the code nowadays. You can just ask it for the code and it's there. So this saves a lot of time. Speech-to-speech conversion uses this NLP techniques. So different languages, you can language translation. Text-to-speech is you give an input text and it'll speak it out for you. Now, use cases of GI models across the domains, in all it's in all the domains. So in healthcare, of course, the speaker said how it's used in healthcare, and then for art and animation. So all of you play games, right? On PS4, etc. So how does the animation work there? How does the characters smile and how does it run? It's all this. It's all AI. According to whatever input you give, right? Marketing and sales, as I told you, is about targeted marketing, targeted audiences. And supposing you enter a shop, and depending upon your facial expressions, it can actually find out what products you are inclined to, what do you want, and supposing they give you a questionnaire. You have positive and negative words, right? Using those positive and negative words, it finds out what your preferences are. Some of the AI tools, Gretel Genie AI. Genie AI is for law firms. Law firms use that. And Pictory is another one for image generation. And these are the services which you can use. The services offered by Azure. Azure Face API, custom vision, and machine learning. Now, the Face API, this can be used in security systems, access control to allow access and user authentication, etc. Now, face detection. So, camera is there, right? I mean, like you have a camera in public places. So, you've seen movies, right? How do they actually detect the face? With a square around the face, right? With a square around the face. So that is face detection. You can detect the faces and verify the face if you are searching for somebody or you want to recognize the face and you can identify certain people. Now, Azure Custom Vision, okay? This is an API which can be used for image analysis and image classification and all that. Supposing, now we are going to use this for facial recognition system. Language services, as I told you, like text to speech and different they translate for different languages and using NLP techniques. Now Azure Machine Learning, it has machine learning capabilities. You can incorporate all these algorithms to perform different application tasks. So this is a face recognition generative AI. So you know how this works is, instead of giving text as data sets, we give images as data sets. The more images you give, the more images it can map to and produce very robust applications, okay, and identify. So once you give an image, it can identify from the plethora of images which is already in its database and give you your results. And these are the steps for face recognition system. First of all, we get all the images and prepare it in such a way in the same format and feed it into the system, and then train a GAN and then a face recognition model. And then you use an algorithm called convolutional neural network for this. And then face recognition model and the generative model has to be integrated. So this is the basic thing with how it works. In the face recognition system, there are 3 Azure functions which are used. First of all, you register the user and you train the image so that the image is got and it's stored. And then once the same image, same user logs in, it is from the storage. It is it finds out and it detects and identifies the system. Now you can also add like character analysis using, in this application. Like, instead of only the images of the face and facial images, right? We can add certain characteristics to every, certain characteristics. Like you can find out the character of a person by, using this. If you add in more information regarding the characters. Yeah. So these are all used in virtual try-on and fashion and facial expression generator, as in the video games, and avatar creation in your WhatsApp and all. Now facial aging simulation is done, you have an app, right? Which you can calculate the age, that kind of things. Now this is now, there is a lot of things, ethical thing also you have to take care of, and the accuracy of this system basically depends on the amount of images you add. So the more data you give it, the more accurate and robust, it can identify. So that's what I told you, character analysis. This is one more thing which you can use it. You can use it for defense before you take people. And biometric facial recognition is already there. I mean, for fraud prevention and credit card and all that. So this is how Azure can be used for generating these kind of applications. This is just an application which I've given for an example. So using this, these are the models which are used. These are different APIs which are used. And using this, you can actually create with your own ideas. You can put your own ideas into practice. Any questions? Thank you.
Thank you, ma'am, for your valuable insight on generative AI in Azure platform.
Mr. Niranjan Kumar, an AI researcher at TUM Germany, whose groundbreaking work delves into the realm of Gen AI in algorithms. Stay tuned to unravel the mysteries of Gen AI and its potential to reshape the future of algorithmic design. I invite you, sir, to enlighten the gathering on Gen AI in algorithms.
Good evening, everyone. So I am short on time, so hopefully my presentation will also be short and sweet. So I'm going to be talking about backpropagation and how it's going to be used in generative AI. And hopefully I can cover the generative AI part pretty well. Let's see how it goes. Okay. So optimize some function, right? We don't know a lot about this function, but we want to optimize it. Oh yeah, and one more thing. So I will be using some math notation. If anyone doesn't get it, just tell me you don't understand the notation, because I will explain it. All right. So the goal is to minimize or maximize some function which we don't really know beforehand. We don't know how the function looks like, right? So the function is from a high dimension space, like Rn, and it goes to like R. So it takes in a lot of numbers and gives you one number, basically. And you want to minimize this number. You want to find out for what values I get a smaller number. And usually this is not possible. Like usually if you have some random function, this is not possible. But we are lucky in the case of AI that it's actually differentiable. Okay, and all of you know like differentiable and everything, right? Yeah, obviously. Okay, cool. So this function is differentiable as in it's very smooth. So if I move a bit, that means the output also moves a bit. So I think I'll give you a better example, right? So suppose I just take you, and I put you in the middle of the hills, right? Like I just take you and you're in the middle of the hills. I just drop you in a random place, and I ask you to find the lowest point. Like how would you do it, right? So one way would be to just walk around the entire place, like walk everywhere, keep a track of your current altitude at every single point in time, and eventually be like, yeah, this is the lowest. Like we don't know when, but you just say, yeah, I found the lowest point. Another way would be to climb to the highest point and look at the entire area and then decide, yeah, that place is lowest. I'm going to go there. But both of these are not possible for us because we don't actually, like this is a function, right? This is not a mountain. So we do something more natural, which is if I'm on the mountain, I just look at the ground And whichever way it's sloping, I just walk down, right? So if I'm on the stairs and I want to go lower, I just go down the stairs. Like, that's it. So that's the same thing we do. So we just differentiate the function to find out the slope of the ground. You differentiate the function, you find out how the ground is sloped, and you just walk down that slope. That's all you're doing. So this is the derivative of the function at a point. So around that point, the function can be written like this. Okay, I'm not going to go into the details, but basically what this is saying is I'm differentiating it, and I'm just going to walk down that slope by a very small amount. That v there is very small. So this is the derivative, right? So I change my current position to the position minus the slope by a very small amount. So I just keep walking down, and hopefully I reach the minimum. Okay, I do have an example for this, which is why I wanted my laptop out. So you guys can scan that if you have your phones, and it'll take you to a graph which I have set up. Or you can just watch, right? So this is your initial point. Okay, hold on. Yeah, so you can think of these like the mountains, right? And this is my initial point. So you see, it just calculates the slope and walks down, calculates the slope and walks down. And eventually it goes all the way down. So if you guys want to try this with some other function, you can scan this and change the function and play around with it. But the basic idea is where you just calculate the derivative at every point and keep going down. Now, finding what to optimize is also a problem, which I do not want to explain right now. But okay, so basically, this is how a normal neural network works. But this is not generative AI, so I want to do the generative AI part. So I'll skim over all of this. So if you have experience with neural networks, this is just a perceptron, and this is the function which you want to optimize. The sigma is just a function which gives you a small number, basically. So this is the function you want to optimize in terms of this wi and b. So I keep differentiating it and minimizing the output. Right? Yeah, so this is the error in a neural network, which is basically the output minus the desired value. Like the output of the neural network minus the desired value is the difference between what the network is giving me and what I want, and I want to minimize this value. Right? Okay. So it's a fun exercise to do differentiation, so I will let you guys differentiate it yourself, actually. This is how a neuron looks like. And you just build multiple layers of them. And if you want a better version of the question, I will tell it to you later. But I would like you guys to find these formulas yourself, just by differentiating, right? But like, I do have the answers here if you want it, but it's not important. Okay, so I'll skip all this again. I want to talk about generative AI. And so basically, as Shivakumar sir had told us earlier, the generative AI can be boring and difficult to speak about. I hope by the end of this, it's at least not difficult. Right? So the goal behind generative AI is to take a lot of data, compress it into something smaller, and then decompress it to the original data. And by hopes of doing this, you plan to learn patterns in the original data. Right? So you have a very large input, and you want to compress it to something small, and you want to decompress it again. And when you compress it to something small, you hope to actually extract features of the data. Right? So, for example, like, okay, I have a nice example. So maybe if I want to reconstruct faces, right, from this crowd, I want to reconstruct faces from this crowd. So what I'll do is like I'll take a picture of every single one of you, and that becomes my input. But along with the faces, I also add in the position where you're sitting in, right? So this is the picture of your face and the position where you're sitting in. And then I feed it into the network. And I've reduced it to only like three variables. And then I decompress it again, right? So now something interesting will happen. It's that in these 3 variables, I'm storing some information that's enough to generate a face, basically. Right? I started with so much data, but in the end, in just these 3, I can generate a face. So I can give some random values here, and I'll get a random face. Right? So, okay, but the reason I added the location data is also to like kind of explain why data cleaning is important. Because I added the location data here, and there is a very clear bias in the location here, right? So maybe these 2 variables just capture the location you are in. And if you're to my left, it just generates the picture of an arbitrary woman. And if it's to the right, it just generates a picture of an arbitrary man. Even though that's not the features you wanted to extract, it'll still do it because our data was so biased, right? So you need to have good data to begin with, and then you get good outputs. But either way, this will extract features from the data and then output it, right? And again, so you get the same error function, which you use backpropagation, gradient descent to optimize. So like the algorithms I spoke in the beginning is what's used here. Yeah, okay. So an autoencoder is basically the picture which I showed you, right? Like this entire thing is called an autoencoder, where the input is the encoder and this is the decoder. And both are trained like together, both start off randomly and they're trained together to generate a very good decoder. What we're chasing is a really good decoder which can generate data we want from just these 3 variables. So then to generate a new image, I just give random values here and it generates something new. So, okay. I will just skim over this, but basically, so what attention is, it's another very important building block in AI right now, which you all should be using if you build large networks. So basically what it does is it takes a query, a key, and values. So key and values are data you want to influence, and a query is data you want to influence by, right? So for example, a prompt generation as in like, so someone spoke about generating images from prompts, right? So I want to affect the image, so that would be the key and value data, by the text, which is the query data, right? So you can forget about all these formulas, like you can find them online. Like I don't have time to explain them right now. But so this is basically how stable diffusion works. So what it does is, this is the encoder on top. It takes a big image, makes it small, and then it uses this attention mechanism to change the compressed image based on the text you have given it, right? And then it just decompresses it again. The decoder works here. So by the end of it, you have an image which is original, but it's influenced by the text you gave it. And you train this by a large data set of captioned images. So that's how stable diffusion works. And this diffusion process is not direct. It happens, it goes through again and again, slowly, like decoding and decoding the image. Okay, hold on. So over here, yeah, I talk about denoising autoencoders, where before encoding, I blur the image a bit. And the reason you blur it is so that you can add noise and randomness to the image so that you get a random output as well. You don't want it to be a copy, right? You want something new. So that's why you blur it a bit while training. And this is actually really, really cool. So when you run stable diffusion, this is how it looks. It starts with something very blurred, and it slowly unblurs it based on the text prompt you have given. And based on the text prompt is because of this attention mechanism, right? This attention. And the unblurring is because of these autoencoders, right? And everything is trained using backpropagation and the optimization I spoke about in the beginning. You just keep differentiating and minimizing the error. That's it, right? So like, this is really cool. Like, I don't know, it looks really nice because you start from something completely random and you end up with a very recognizable image of like a castle. And this is the same thing with text generation as well. You just keep inputting the output text you get as input, and it figures out what to say next. And that's how ChatGPT and everything works. Like, I mean, so these are the 3 references I used. If you guys are interested, you can read more about all of them. Like, I can give you the links for everything. And if you're just generally interested in talking more about this, I'm also free after this. All right, yeah. Thank you. I mean, do you have any questions? Yeah, yeah.
Suppose we have a set of constraints. Yeah. A lot of restriction in individual variables. How you can interpret? Yeah. Sir?
Speaker like
Sir, you are talking about optimization of a single function that involves a variable that are takes only positive and is differentiable. Okay. Suppose we give a set of constraints. What we do at the time?
So you want to add constraints to it?
Yes.
So the function I'm optimizing is the loss function or the error function. So I have one function which is differentiable, and I want to optimize that with respect to something else, which are the constraints you're talking about. So that is the loss function.
The function involves some 10 variables.
Yeah.
Among the 10 variables, there is a relation between 2 variables, 3 variables,
Yeah.
like that. But there is a restriction also.
Yeah.
Suppose the variable x1 means x1 does not exceed 0 to 1.
Okay, yeah. So if you want to add restrictions, you can do like Lagrange multipliers or something like that.
So at
But
that time, how to interpret this?
But that is not used here because there is no restriction, because they're all independent variables. That is an assumption you make in the, like before. But if they are dependent, you can use Lagrange multipliers, but that will increase the computation by a lot. It won't become parallelizable
Is it
anymore.
possible to interpret mixed variables?
It definitely.
Some type of variable assumes only integer. Suppose x represents number of persons means number of persons is always an integer.
Yeah.
Time means it varies from 1.2 seconds, 1.2 hour, like that.
Yeah.
So is it possible to interpret mixed variables?
Okay, see, I didn't understand your question completely. If you could rephrase it a bit and say it to me again, it would be better. Like,
Sir, now variables is you are saying that in optimization we are considering only positive variables. Instead of positive, suppose we want to use real variables that takes from 0 to 1, any value in between 0 to 1.
it's possible. It's possible. You just have to have the correct error function. If I want to minimize, I can go negative as well.
Can we restrict the interval?
Yeah. It's all possible.
Possible.
It's everything. Like,
With expertise in NMC operation, maintenance and optimization, I invite you, sir, to enlighten the gathering on Generation AI and 5G. Sir, please.
Everyone, I think MPPT போறதுக்கு கொஞ்சம் லேட் ஆகும் போல இருக்கு. In between, I'll speak with you for some time. Everyone has spoke to you about edge computing, IoT, a lot of things. It's an example like how to come to a PSNA college. The destination is PSNA college, right? I came from Dindigul towards PSNA college. My source and destination was fixed. But how do I come? That's where the 5G works. So that's where I'm here to talk to you. So the point is like, depends like how you can come. You can come by a mode of a car or a bus or a cycle. Even I can walk and come. So that's where the technology revolution starts over here. So for example, now we are talking about the 5Gs and everything to you guys, but initially we started with the 1G, like how our initial transportations were on the bullock carts. So the same way, there's a revolution of this 5G which has came down. The era of 5G started with the 1G. So like initially we had an, what I can say, like, நம்ம வீட்டிலலாம் பார்த்தீங்கன்னா we had on telephones, right? We had on landline phones. எல்லாம் டயல் பண்ணிட்டு இருந்தோம் அப்படி இப்படின்னு. ஸோ ஆஃப்டர் சம் டேஸ் இட் ஹஸ் பிகம் அ பட்டன் ஃபோன்ஸ். ஸோ தே டிசைடட் எவ்வளோ நாள் தான் நம்ம we can sit and speak in a one single place, fixed line, right? So they decided to have a movable interface. So they decided the point where this mobile has came into the technology. And the interface, we use an air interface. So எப்படி நீங்கள் ரேடியோ சேனல்ஸில் வந்து டியூன் பண்ணி பார்க்குறீங்க 93.5 something like that. So we have a frequency over there for in the telecom interfaces for each and everything. So the first part was started with 1G, like நீங்கள் அந்த காலத்தில் நோக்கியாவில் செங்கல் ஃபோன்னு சொல்லி கேள்விப்பட்டிருப்பீங்க, okay? So that are the phones that have been used. So where we were doing the first thing was on a voice call. So we used to talk with each other on the voice calls. And the next enhancement was done on the SMS, okay? So next, the point is that we started browsing, like in our laptops and on the systems, we start browsing, right? The browsing technology, other one we have started converting into an air interface there when comes the 3G, okay? Thank you. And the data rate speed was like low frequency layer, like or google.com நீங்க search பண்ணீங்கன்னா it takes a long time, right? So அந்த space வந்து fill பண்ண we next moved on to a technology called 4G, okay, where your data rate speed got increased, okay, like Google streaming லாம் பாத்தீங்கன்னா it will be in a very Gbps speeds, okay, and move on. Then we came into 5G. This 5G is nothing but a slicing techniques will be used on. So this was a point which I was talking to you now just a minute before, saying to you like how to travel to PSNE. So the option of choosing it, cycle, a bullock cart, or a car, or a fast motorcycle. So I decide it's like the way we transport, it's known as a technology which is used for this edge and IoT service to be done, okay. So I was explaining you about each technology and the speeds and where it has been utilized. So the point over here is that the first generation of 1G was used only for the voice services, and next it was for the 2G, it was used for voice and data services, and next comes into between a 2.5G, that's known as edge. Now if edge computing the edgingara vartha it came to before itself in the form of the 3G was a baseline for a data structure to bring on an air interface that was tested on another platform called edge computing. Edge அப்படிங்கற ஒருல கொண்டு வந்தாங்க. That was known as 2.5G, okay. In the 3G, like you can see the video streaming, everything. Like your WhatsApp calls, what you're using guys right now, you can see the video calls and your voice calls all being streamed on the 4G things. When we have a 4G technology, the point is like we were using a third party application like WhatsApp, Skype or Zoom to make your voice call and a video call, right? So there was another interface which we brought inside a domain called IMS domain, where all your applications and whatever the streaming what you're looking for has been incorporated into the telecom sectors. So if you see in your current phones, you easier or voice call pannalam or video call pannalam, okay, no need an applications for you, right? So and the processing nadakapodhu vandha IMS technology, okay. So now where the 5G plays a main role over here. For example, in your phone you are using two applications, okay. One is to run your emails, another one is to make your video call. Surely your data interference is a problem over there. So we introduce a technology called slicing over there. The slicing will happens into 5 phases in 5G, okay. So when you're using a 4G network, okay, your data rates has been in a constant thing. Like there was only one single data rate, for example 4 Mbps or 5 Mbps or 4 Gbps was a data rate. But when you use a 5G technology, it can be sliced out. Even your phones become an intelligence over there, like your applications can be classified. For example, your Outlook can be used for EMBB services. Your like if driving a remoteless car or a real-time examples you will be used, that can be used for URLCC and an enhanced LTE networks and IoT. So this has been classified, okay. So in the 5G, what is the main point is that we have 5 key points over here. In this spider diagram, I would have explained you very better well. Like you can get low latency, reliability, and a peak data, right? And a coverage and low cost and a battery life. These are the key points of 5G, okay. In a phone, if you start using an enhanced broadband services, what will be an outcome of it? That means when you use an enhanced broadband services, which is on the pink line, your latency will be in 80%. Your peak data rate will be good, but your coverage will be less. So what happens means you have to use a small scale cells over there to cover the services, and your cost will be too high. So that means the low cost has not been enabled over there, and your battery life also goes down. Okay, so the services will get changed according to the use case what you are using. That's why you can think where it's going to be used in a real-time examples. Okay, say in the agriculture industry, in a healthcare industry, or in an automobile industry, everywhere it is used. A speaker who speak before me about a text to speech, okay, that is being enabled on your phones in a WhatsApp. Just have a Google pad இருந்ததுனா அல்ல நீங்க ஸ்பீக் உங்களோட மைக்கை கிளிக் பண்ணி you start speaking, no, it starts printing yourself. That means the Gen AI is being enabled over there. But on the speed நாம் obtain பண்றதுக்கு we need a network which has a very low latency and it has to be fast data processed. So low latency use பண்ற network we use a 5G, and that thing has to be supported by an hardware, right? That will be done by an edge computing. Okay, this is where the edge computing comes into the place. Okay, because edge computing is already, எப்படி சொல்றதுனா, you have been come across your life everything. Like first we started with a basic computer, then we moved to a laptop, then we moved to a server, and the server where we have a redundancy of the applications. Then we decided that hardware has to be also redundancy. Then we moved to a computing. Okay, in the computing, if one server goes down, the other server takes the services. Now, to make the centralized system has to be decentralized, they decided to get a faster rate, they brought this edge computing services. So, in your real-time examples, you can see this Raspberry Pi is a best example of your IoT device with an edge computing. Even your phones also, like for example, இப்போலாம் வந்து நீங்கள் கேட்குற சாங்ஸாக இருக்கட்டும், வீடியோஸாக இருக்கட்டும், you are seeing through an online streaming apps, right? So that the database is stored on a cloud, okay? And the point, like for example, you watch a movie, and again if you start watching the same movie, the database will be stored in a cache memory that is on the edge of it. So now உங்களோட buffering period is get reduced. Okay, so இப்போ வந்து இல்லை எப்படி I'm trying to relate to you is that your device is an IoT. Okay, the service which is given to you is on the edge, and the end and the service which you are getting in a faster rate is where the 5G technology is being used. Okay, any questions till now? எல்லாம் கிளம்புற மோடில் இருக்கீங்களா? என்னாச்சு இருந்தால் சொல்லிடுங்க. I'll make the PPT very short. What do you say, connection? Yeah, move it on. So the edge computing I was saying to you guys, okay? See, in this PPT, just see the last line. See, in 1960, the mainframe, we have a centralized concept we had, okay? Then we decided to move and decentralized concept where we brought these machines, like client and server machines were being brought over there, okay? Again, they decided to be a centralized where we brought a cloud computing, okay? 3B it has become a decentralized using an edge computing. So all the technologies has been old technology is getting replaced with the new names, and end of the day, the data rate speed has to be obtained on it. So that's why we are using all this edge computing and 5G technologies. Like we are talking about this Gen AI, right? Like your chat GPTs or your text to speech. எல்லாமே வந்து உங்களோட the way like நீங்க சொல்லி within a minute you are getting that response means this all been managed by a 5G network with an edge computing hardware systems. Okay, so time is short. I'm just closing my session over here. Any questions? You're open to ask me. Thank you.
For such an interesting session on Gen AI in 5G technology.